start now. After 2 minutes, we shall wait. Stop. Stop the video. I think we should stop it. I don't know. Good evening, ladies and gentlemen. A very warm welcome to all participants who have joined us for this 6-day AICTE-sponsored FDP on exploring the foundations and applications of quantum computing, bridging theory and practices, commencing today. I extend my hearty welcome to Dr. Shraddha Kanwar, Chief Academic Officer, JAIN deemed to be University, Dr. Sagar Gulati, Director of School of CSIT, and all distinguished speakers of this evening, particularly Dr. Anand Nair, who is present here. Before we begin, let us seek the blessings of God Almighty for the successful and seamless conduct of this faculty development program. I request the team to play the invocation song.
शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Good evening, ladies and gentlemen. Hearty welcome to all of you again. It is truly wonderful to see such a diverse and enthusiastic group of over 250 participants from various states across our nation. Your presence here today is a testament to your dedication to knowledge and your passion for this transformative field of quantum computing. Thank you for taking the time to be a part of this program. Quantum computing is not just a technological advancement, it is a strategic imperative. In this context, this FDP holds special significance. It aligns perfectly with the objectives of the National Quantum Mission of India, a landmark initiative with a budgetary outlay of 6,000 crores to foster a robust ecosystem for quantum technology development in our country. This mission aims to catapult India to the forefront of the global quantum landscape. By participating in this program, you are not merely learning a new technology, you are becoming an integral part of this national endeavor. This mission success depends on building a skilled workforce, fostering cutting-edge research, and developing a thriving academic community. All are the very goals of this FDP. Over the next 6 days, we will embark on a fascinating journey guided by experts from both academia and industry. Our sessions are meticulously designed to cover a broad spectrum of topics, from the foundational principles of qubits to advanced concepts in quantum cryptography, machine learning, and hardware architectures. We will also discuss the latest happenings in the present noisy intermediate scale quantum era. We'll try to equip you with the robust knowledge needed to carry out interdisciplinary research and curriculum development at your institutions. I hope this program will be an enriching and insightful experience for each one of you. Let us seize this opportunity to learn, collaborate, and explore the immense possibilities that the future of quantum computing holds, as we collectively contribute to the India's technological future. Thank you once again for joining us. Let us make this 6 days truly productive and memorable. Thank you. Thank you all.
Thank you, Dr. Oja, sir. So it's my privilege to welcome Dr. Sagar Gulati, Director, School of CSIT, JAIN deemed to be University, Bangalore. Dr. Sagar Gulati is a distinguished academic leader with over 15 years of experience in various areas of higher education, including institution building, research, and administration. He currently holds the position of Director for School of CSIT at JAIN deemed to be University, Bangalore, India. His notable roles include serving as a strategic advisor for World Bank-sponsored STRIPE project and being the founding director of Terry Technology Business Incubator. He is also a respected member of Board of Governors at the Inventipreneur Chamber of Commerce and Industry and Board of Advisors at IREU Universe. Dr. Gulati's contribution to the higher education has been recognized with awards such as Eminent Engineering Personality Award from the Institution of Engineers, India, and appreciation awards from the governors of Odisha and Himachal Pradesh. His research is primarily focused on distributed systems, artificial intelligence, wireless network, and he has significant number of publication and industry-sponsored projects to his name. I request Dr. Sagar Gulati, sir, to deliver the opening address.
Thank you so much, Dr. Taskeen, Dr. Oja, the organizers of this FTP. Most respected Dr. Shraddha Kanwar, Chief Academic Officer, JAIN deemed to be University. Dr. Anand Nair, who has joined us from Vietnam, if I'm correct. Dr. Sunita, Head Department of CSNIT, all faculty colleagues at School of CSNIT, and all faculty colleagues from different parts of India, and maybe some of you are joining from different parts of the world. At the outset and first and foremost, let us convey our gratitude to AICT, Ministry of Education, Government of India for creating such a wonderful, robust platform for educators to connect with each other, share knowledge, network, and create a partnership which can stay for a longer duration. Well, I'll be very honest, these FDPs are the ideal platform wherein we can connect with all the eminent speakers who would be joining from different parts. It can be an ideal cornerstone for collaborative research and submitting collaborative proposals as well. To set the context, I look at my own journey. So I think we started from the assembly language, zeros and ones, and then we learned C, then we moved to Java, C++, Python, and then the era of Chat GPT. And in the era of Chat GPT, the moment when we had started feeling that it's no more the zeros and ones, English has become the programming language. We were taught, I think 20 years back, because we have to communicate with the computer, we have to learn the language that computer understands. Now, computer evolved so much that in 20 years of my personal experience and journey, computer has started understanding our language. And now this new term quantum is again disrupting and telling that it's not 0 and 1, it's not the bits. There is a concept of qubits. I think the classical examples of coin being tossed and making us understand that there's a state between 0 and 1 when before the coin falls on one side of the story. So we understood the term called superposition. We gained some part of mastery, then we heard the term of entanglement. And then Dr. Oja used a word called quantum cryptography, which is a kind of a word of caution for all the people around the world, because the current internet banking and all your Aadhaar authentication, your PAN authentication, when everything is linked to RSA encryption algorithms. So people have started saying that the quantum will take maybe few hours to break the entire thing, and we have to further advance. So it tells the 12th PO for engineering education that we have been teaching to our students and we have been defending to NBA, which is the lifelong learning. I think that's the only way forward for all of us. All the educators have to be lifelong learners, and then only we can expect and imagine any journey forward possible. With this, I extend my best wishes to this wonderful FDP, which has been curated by my colleagues so thoughtfully. I've been seeing their hard work, reaching out to experts, connecting with different stakeholders of higher education, reaching out to all the participants. So being an internal stakeholder, I can very confidently say that a lot of hard work, a lot of thought process has gone in designing of this program. Very learned speakers have been finalized. So it should not be a COVID class. You all should be active learners. There should not be, though quantum tells us that you can imagine a situation wherein a Virat Kohli is playing 10 balls simultaneously. My advice is you all be in the non-quantum world while being the audience of this FDP to gain the benefits, the most benefits out of it, and to listen to all the learned speakers who have joined in. My best wishes to the organizers, to the attendees from different parts of India and the world, and to the head of the department, and to the organizers, and to all of you. Good luck. Have very good, very meaningful, very engaging next few days of learning quantum computing, theory as well as practice. Thank you. Dr. Taskeen, you can please take it over.
Thank you, Dr. Sagar, sir, for a truly thought-provoking inaugural address. Sir, your presence is a testament to importance you place on advancing our knowledge and embracing the future of technology. Thanks you once again, not just for your time today, but for your vision and leadership that continue to motivate us all. Now it is my privilege to welcome Dr. Shraddha Kanwar, Chief Academic Officer, JAIN Deemed to be University. Dr. Shraddha Kanwar is the Chief Academic Officer at JAIN Deemed to be University with 26 years of diverse experience in academia and industry. Her work is focused on transforming education into modern era with the research specialization in talent development, digital enablement, and building innovative learning ecosystem. She holds the PhD in liberal arts and has developed expertise in emerging technologies, with her competence being recognized by the leading institutions globally. I request Dr. Shraddha ma'am to come and just deliver the inaugural session.
Good evening and thank you. I apologize for my bad voice, and I'm going to therefore switch off the video because I need to keep the phone very close to my face and speak a little louder as much as I can. Good evening, everybody. A very, very warm welcome on behalf of JAIN Deemed to be University to this FDP, which is on exploring the foundations and applications of quantum computing, bridging theory and practice. Dr. Sagar Gulati, Dr. Roja, and all the faculty members of the Department of CS and IT, and all the invited faculty members who've enrolled for this workshop. I think this is an amazing, amazing topic. Dr. Ojha mentioned about the quantum mission of India, and it has a great prospect. Dr. Sagar Gulati spoke about several things, and we've been having so many conversations around quantum computing, quantum entanglement, and multiple other facets of qubits, etc., which govern the very identity of what is quantum. If we reflect on what we are doing today as part of this wonderful workshop, it is really exploring different facets of quantum computing. And there is no denying that the advent of quantum computing is poised to have a transformative impact on the future. And what this really brings us towards is an opportunity. The opportunity to solve more complex problems, the opportunity to solve these complex problems probably in a more exponential manner, because of course qubits and computing and processing etc. becomes much more advanced and expedited. So today, if we look at the word quantum itself, and I would want to share this with you because as I was invited to speak over here, I was very curious to know what the word quantum means. We use it so much, and it's like such a buzzword. It's a very simple word which means how much. So the word quantum actually means how much. And my request to all the participants today is to reflect on this. How much are you going to learn through these 6 days of the workshop that you're going to do and be participating in? How much are you going to take back to your respective institutes as part of the knowledge transfer? And how much are you going to contribute towards making quantum computing and the mission in India and our future endeavors towards complex problem solving, towards innovating, towards doing something very differently, and also towards safeguarding our interests as a nation? And how much can we contribute towards India becoming a innovation hub through quantum computing? So a very, very warm welcome again, and would wish all of you a great time, great learning time, and remember the how much that you take away. Thank you so much.
Thank you, Shraddha ma'am. Despite your poor health, we are extremely grateful to you for attending and sharing the ideas during this FDP inaugural address. As a Chief Academic Officer, your passion for transforming education is truly inspiring. And I will also like to express my thanks to AICT ATAL for sponsoring this FDP. Special thanks to our Chancellor, Dr. Chenraj Raichand, our Vice Chancellor in charge, Dr. Jiten Kumar Mishra, and principal officers. Now we are closing this inaugural session and we are taking 2-3 minutes break so that we will start commencing our session number 1 within 2-3 minutes.
Ever wondered where the future begins? Every journey begins with a step. For us, this was the beginning of something bigger. We weren't just stepping into a university, we were stepping into a future we were about to create. Some of us came here with a plan, some with curiosity. But all of us had one thing in common: an urge to build, an urge to create and innovate. This is where passion meets purpose, where dreams don't stay dreams. Here, we don't just learn, we create, we question, we break, we build. We believe every problem is an opportunity. Here, every student is on their own path, discovering, creating, and redefining the future. Some write codes that power the world. Some secure the digital landscape. Some decode the future of tech. Some turn imagination into motion. Some dream, build, and lead. Here at the School of CS and IT, learning isn't just theory, It's learning, unlearning, and relearning. It is creating the world out of pixels and turning knowledge into action. At the School of CS and IT, we don't just get educated. Our aspirations take shape, skills evolve, and ideas turn into achievements. Through innovation, technology, and hands-on experience, we weren't just prepared for the future. Instead, we created it. Join us and be a part of a future driven by technology and innovation. Ever wondered where the future begins? Every journey begins with a step. For us, this was the beginning of something bigger. We weren't just stepping into a university, we were stepping into a future we were about to create. Some of us came here with a plan, some with curiosity. But all of us had one thing in common: an urge to build, an urge to create and innovate. This is where passion meets purpose, where dreams don't stay dreams. Here, we don't just learn, we create, we question, we break, we build. We believe every problem is an opportunity. Here, every student is on their own path, discovering, creating, and redefining the future. Some write codes that power the world. Some secure the digital landscape. Some decode the future of tech. Some turn imagination into motion. Some dream, build, and lead. Here at the School of CS and IT, learning isn't just theory. It's learning, unlearning, and relearning. It is creating the world out of pixels and turning knowledge into action. At the School of CS and IT, we don't just get educated. Our aspirations take shape, skills evolve, and ideas turn into achievements. Through innovation, technology, and hands-on experience, we weren't just prepared for the future. Instead, we created it. Join us and be a part of a future driven by technology and innovation.
Good evening, esteemed participants. May I have your attention, please? We are going to start the session for the day. To ensure a smooth and productive experience for everyone, I would like to quickly walk you through the schedule and some important guidelines. As you know from the program schedule circulated to you, the FDP commences today and concludes on September 30th. Every day sessions are scheduled from 6:30 p.m. to 9:30 p.m. except for the final day, that is September 13th, where sessions will run from 2 p.m. to 6:30 p.m. On the final day, we shall have the participants' feedback. Some of the participants will be allowed to speak on the FDP program. Then we shall have the test from 6:30 to 7:30 p.m., followed by the valedictory session from 7:30 p.m. to 8 p.m. So all the participants are requested to log in 5 minutes before the scheduled time every day to avoid any disruptions. A minimum of 80% attendance is required for successful completion of the FDP program. Attendance will be based on your active participation throughout the sessions and submission of the feedback forms. Your feedback is crucial for the success of this program. A feedback form will be circulated online each day after the session is over. So please note that this form will remain active for only 30 minutes. So we encourage you to complete it promptly. The final online test will be conducted on the AICT portal on the last day of the FDP from 7 p.m. to 7:30 p.m. The test will consist of 20 questions with each correct answer carrying 1 mark. To successfully pass the test and receive the FDP certificate, you must achieve a minimum score of 70%, that is 14 marks out of 20 marks in the test, and a minimum of 80% attendance together. Upon passing, you will be able to download the digital certificate directly from the AICT portal. For a seamless experience for all, please ensure your microphones are muted throughout the sessions unless you are invited to speak. If you have a question, please feel free to use the chat box to type it, and our team will ensure it gets addressed during question answer session. We are confident that this FDP will be a rewarding experience for you all. We look forward to your active participation and a week of insightful learning. Thank you all. Thank you.
Thanks, Dr. Oja sir. Good evening, participants. Now it is my privilege to welcome Dr. Anand Nayyar for delivering the session 1 on Introduction to Quantum Computing Foundations and Motivations. Dr. Nayyar is a professor, senior scientist, vice chairman at the School of Computer Science, Dutan University in Vietnam. He also serves as the director of IoT and Intelligent Systems Lab. He's earned his PhD in computer science in 2017 from Deshbhagat University, specializing in wireless sensor networks, swarm intelligence, and network simulation. He is a certified professional with over 280 certifications from various companies, including Cisco, Microsoft, and Google. Dr. Nayyar has an excellent publication record with more than 200 research papers in high-quality journals and over 80 papers in international conferences. His research has garnered over 20,500 citations on Google Scholar and more than 11,800 on Scopus. He has also co-authored over 70 computer science books. His research interests include wireless sensor network, Internet of Things, swarm intelligence, cloud computing, artificial intelligence, drones, blockchain, cybersecurity, healthcare informatics, big data, wireless communication. He also holds numerous patents and copyrights from various countries, including Australia, Germany, Japan, India, UK, USA, and Canada. Dr. Nayyar has received 55 awards for his contributions to the teaching and research, including Young Scientist, Best Senior Scientist, and DTU Best Professor and Researcher Award. He has been listed among top 2% scientists by Stanford University from 2019 to 2023. He is also ranked in top scientist for computer science in Vietnam by research.com. He is also senior member of IEEE and ACM and is an associate editor for several journals, including Computer Communications from Elsevier and IEEE Transactions on Artificial Intelligence. I request Dr. Anand Nayyar to deliver the session 1 of the FDP.
Thank you so much, ma'am, for my introduction. Can you hear me?
Yes, sir, you are audible, sir.
Okay, thank you. I'm now sharing my screen, please. Give me the request approval. Good evening, good afternoon, ladies and gentlemen. I'm Professor Dr. Anand Nayyar, and I'm working as Professor, Scientist, Vice Chairman Research, and Director of IoT and Intelligent Systems Lab at the School of Computer Science, Dutan University, Da Nang, Vietnam. First of all, it's a real honor for me to be acting as the speaker in this ATAL and AICTE sponsored FDP program on quantum computing. And it's really an honor that Dr. Taskeen has invited me over here. And of course, if you talk about the quantum computing, the stream is actually booming. And of course, if we see the quantum computing from the theoretical concept about 5 years before, and now quantum computing is becoming a reality. And of course, if you talk about countries like China, USA, Korea, Australia, and of course, India, they are investing a huge in quantum computing breakthroughs. In fact, I can say you that the breakthroughs that we have seen in artificial intelligence, we will see most heavily breakthroughs in quantum computing in the next coming 3 to 5 years. So you can say everybody that from year 2026 to 2031, these are the very crucial years in which we can see the dependency of quantum computing as a foundational system, as a server. And of course, the real-time applications will be dependent on quantum computing. So in this FDP program, it is very important for all of you to get updated with this quantum computing scenario. What exactly is quantum computing? Why it is required? What are the real-time applications? How quantum computing actually works? And of course, in this lecture, I will be covering a lot, which I will be telling you. And of course, ladies and gentlemen, please sit back, relax, and enjoy the lecture. And take your pen and paper and please make your notes. And of course, if you want to take a screenshot of any of my presentation, you are most welcome, because I will not be sharing my presentation at the end of this lecture because of some copyrighted material. So at the end of the lecture, there is also some surprise and some hands-on session for all of you, which I have created for you for this FDP program. And I will be also telling you that quantum computing looks very difficult in terms of the approach. But in fact, if you dig more into the quantum computing scenarios, it is like learning about C, Java, or Python programming language. The only thing is that you need to be a little bit good about the quantum physics. And of course, you need to have some knowledge about chemistry and mathematics. And of course, it is a fusion with computer science. So before I start with my lecture, everybody, in which as an opening speaker, I will be motivating you, I will be telling you what exactly is the foundation of quantum computer and everything. I would like to introduce myself, because today why you are lucky and why I'm here. In fact, today everybody, I would like to tell you that I'm one of the persons in among 275 people in the planet who has actually invented quantum computer. So I'm having my own quantum computer, which I have invented last year, about 5 qubit, and about just 3 weeks before we got the major breakthrough in which I have invented the upgradation of my quantum computer to 75 qubits in less than 2.6 million US dollars. So I will be also showing you that. And of course, as an inventor of quantum computer, you are most welcome and encouraged to ask me the questions at the end. So this session will not be ending unless or until I will be giving you the answers of all your questions. So all your questions and everything, all doubts and all confusions are most welcome. So please feel free to give me the questions. And of course, you can type it on chat box at the regular intervals of the lecture. And after the end of the lecture, I will be coming to all those questions. And trust me, none of your questions will be unsolved at the end of the session. So everybody, first of all, let me introduce myself. So you can see that I got the award of the best professor and best researcher, and with about like 80 publications in year 2024. And as a 30th anniversary of the university, it is the highest honor that has been given to any foreigner in Vietnam. So I've been awarded as a National Medal of Research, that is from the government of Da Nang and even from Vietnam government. And it is the new record that you can see on the screen with 290 points, which is the highest ever in 37 years of research in Vietnam. So you can see me as a speaker of Dev Day. It is an event that is being sponsored by Oracle, Microsoft, and Google in Da Nang City. And this year we have done the lecture on AI agents, and I was given as the best speaker award. And in fact, I am the best speaker in Dev Day from the last 4 years. And here are some of my innovations that you can see. So on the left hand side, you can see my robot, and this has already been integrated at the Da Nang International Airport. And very soon this robot will be integrated in coffee shops and hotels. And this month only we have upgraded this robot with some AI agents also, which means that it will be directly connected to Grok 4 and of course with ChatGPT 5.1, that is the language model, and it is going to give you the answers like live you're talking to ChatGPT. So this is my owl. So if you have a HomePod or Alexa, so Alexa and HomePod just control your smart home. So if you're having the smart home, you can put the smart owl. It is actually going to recommend, like suppose that if there is a room and the lights are on and the AC is on, so this owl can even give you the recommendations that what exactly can be done in the smart home. And of course, if you talk about the drone, I have invented my more than 10 to 15 drones, which I will be telling you. I'm having a sophisticated drones lab and robotics lab in Vietnam. So this is the agriculture drone that we have already integrated, and it is completely having 60% of autonomous capability. And by the end of this year, it will be complete FPV drone. We are researching on it. So I'm having more than 18 plus years of teaching and research, and I'm having more than 250 plus publications, and I'm acting as editor-in-chief of IJKSS Journal, which is Scopus Indexed in IJ Global, and I'm associated with 1500 conferences across the planet. So I'm having 10 inventions, 150 plus patents, 10 copyrights, and of course, very soon I will be completing my 100 books. And I'm also among the top 1000 people in the computer science. To be specific, I'm among the top 546 in the area of IoT, artificial intelligence, blockchain, cybersecurity, and wireless communications. So this is my office and lab systems, and you can see the most state-of-the-art lab is already with me, which is costing like 85,000 US dollars to 94,000 US dollars. So this is my workstation where you can say the modern state-of-the-art equipments that you can see, and very soon it will be upgraded to 2 more monitors, and of course we are planning more in order to make it as a setup of about like 35 lakhs as per Indian currency. And this is my portable workstation. Right now I'm streaming my all video over here. So as a YouTuber also, you can even search my YouTube channel. I regularly make YouTube videos, and I'm also doing streaming. And of course, I also teach on LinkedIn also. So you're most welcome to follow me. And very soon I will be teaching on LinkedIn that how we can have the quantum breakthroughs in time machines and all those things. So these are the top quality lab systems that you can see, and all the systems are equipped with not with GB of RAM, but every system is equipped with 1 terabyte of RAM with 18 petabytes of combined data center. So you are having more than like 6 to 7 GPUs that I'm using, and they are all connected to Alibaba Cloud. We are having the most master computer in Alibaba, and we are using it to train our healthcare models, the cloud computing models, and to even integrate some ACA chain based projects, which I will be telling you. And these also are my crypto mining machines we are using. And in fact, apart from being a professor in Dutan University, I'm also an entrepreneur. I'm also a CEO of my own company, which is comprised in Hong Kong, Kuala Lumpur, and of course in Macau. And I'm doing the work of mining, and of course with the more invention of my own crypto mining machines. And of course, I'm doing my research on penetration testing and cloud computing data centers. So this is my robotics lab, and you can see that we are working on nanobots and microbots. And if you talk about the robotics, we are actually well connected to the police and the army over here. So we are supplying them with tons and tons of technology, and we are delivering technology to 3 and 4 multinational companies, which I cannot declare right now because of the conflict of interest. So here are the robots that you can see in front of you, and these are the robots that can perform all type of dancing and disco operations. And of course, this is almost ready. Almost the working prototype is ready by 97%. And these are the small bots that you can see in terms of the octopus, and of course the nanobots. And of course these two bots, everybody understand that this is not an ordinary robot. This is a swarm robot, which means if I give them a task, these robots will actually discuss the task, and of course they will make the task in a parallel manner, and they will follow the swarm intelligence in terms of ant colony optimizations. And this is my lab of complete STEM, and of course with robotic construction, the modern state of the art lab that you can see right now. So if anybody is interested to visit me in Da Nang and Vietnam, please fire an email. You are most welcome to come here, be my guest. And of course, you can have a good visit of my labs, which are available for research. So this is our work in progress. This is a robotic dog. I hope you have seen many videos in Huchong Bay or Shenzhen in China. And of course, the Canton Fair is happening. So this is my robotic dog, and we are actually constructing 50% of technology from China, 20% is from Russia, and 10% from Australia. And rest we are working at our own end with NVIDIA in order to make this robotic dog possible. And till now, we are having the best collaboration with LiDAR and radar-based technologies. And this is my drones lab, everybody. In our drones lab, we are having the most modern state-of-the-art technology that you've ever imagined. And you can see that we are working on these RC planes. And you will be happy to know that we have the most modern state-of-the-art drone simulator also, in which I also support my students to how to become a drone pilot and RC pilot of the future. So we are also using the top state-of-the-art simulators like Microsoft Flight Simulator. We are also using the Drone Sim from DJI. And of course, we are using 2 and 3 more simulators, which I can't declare here. So you can see that we have the CX20, and we also have the Fly Sky based robotic control, the drone controllers, which are the most expensive drone controllers as available of today, because it is supporting both brushless and brushed motors as per the parallel things. And this is our first working RV plane that we have collaborated with one of the university in Korea. And very soon this drone will be elaborated and of course upgraded to FPV drone. And you can see the photograph. And of course, last year I show you the conference also. And this is my FPV drone of 8K RC jet. And this is the conference which I'm telling you. And last year I got the best paper award. And I have already submitted 3 to 7 patents in USA with regard to the vision technology, object tracking, and autonomous capability of this drone. And this is my IoT and Intelligent Systems Lab, in which we are working mostly on healthcare and of course with augmented reality. And you can see this is our robotic arm that we have created, and till date we have the efficiency of around 88% and accuracy of 78%. And very soon, everybody, by the end of this year, I'm expecting, because we have improved the vision algorithms, we have improved the motion sensors, and of course the tracking technology, and we are taking very good help from some of the companies in Shenzhen. And very soon I'm expecting that the efficiency and accuracy will be touching more than 91.64% by the end of December. And after that, we will be filing 2 more patents in USA. And this is my autonomous vehicle that we are working. And right now we are using Stampede and right now the Jetson nanotechnology in order to perform operations not only in the ordinary daylight, but we are working only on the night operations, and of course with complex terrains when we have rainfall and snowfall. So this is another working prototype, and this is actually the autonomous vehicle in which we can even go for some of the main like army operations and X-ray vision operations. So I hope you can see that what kind of vision that we have for this autonomous controller. And this you can see as an exhibition that we have done for our robotics. And very soon, everybody, this robot will making the Da Nang city a highly robotic and sustainable city in the near future. And everybody, the moment that you're all waiting for. So this is the collaboration that I've done with Chungbuk National University with my own quantum computer design. And this is a 5-bit quantum computer, and we have already upgraded to 76 qubit, which I will be showing you the video right now. And our dream is that by the end of next year, that is by September to December 2026, we are expecting that we can create our quantum computer with more than 356 qubits. So you can see my invention. I'm going to play the video in front of you. So this is the quantum computer that you will see, everybody. Live quantum computer. Now this is 76 qubits. You can see the cryogen, and we are implementing and integrating with smart optical fibers and of course with Dell technology. And you can see our servers also. So the research that I'm conducting, I will be showing you.
냉각기술이 엄청 중요하고 에너지 레벨에서 열 때문에 뜨지 않도록 이게 제가
And let me show you the diagram, everybody. This is the diagram that we are collaborating for 326 qubits. And the person you are seeing right now, that he is the co-coordinator of Chungbuk University for the quantum computing operations. So you can see this reality will be becoming, and I'm happy to inform you that if you talk about the most of the innovators of quantum computer, they have done in more than like 5 to 7 million US dollars. We have made this computer possible in less than 2.5 million US dollars. So right now, if you talk about the projects and grants that are right now coming up, so I'm working as a visiting consultant for FPT software, and we are working on ACA chain project, in which is a complete blockchain project in Vietnam, in which we can do the online shopping from Lazada, Alibaba, and AliExpress in Da Nang city, or by the mid of Q2 of 2026, in which we can be able to pay not only with the cash on delivery or credit card and debit card, we can even pay them with the help of our crypto. So we can also do some implementations also with hospitals. And of course, I'm also working with some of the hospitals in Thailand for electronic healthcare for medical records. And this is my ongoing project with artificial intelligence based LLM business application under Global 30. And I'm also under the process to integrate quantum computer with more than you can say 326 qubits by the end of next year. So these are my links that you can see. You can search me on Google Scholar, on Scopus, on Publons, Web of Science. In fact, you can just search my name on Google. It's a big name. You can even follow my research on ResearchGate. You can see me on Amazon. You can see me on YouTube, ORCID, DBLP. You can just name everything. In fact, you are most encouraged to add me on LinkedIn also. I will be more than happy to make you as a connection of mine. So my three mottos for all of you, I know most of you are here as a raw person that you don't know what is quantum, and some of the people might be having some experience, I don't know, but I assume with this lecture that you are all having the novices, which means that you don't know much of the quantum computing information, because the beginning of wisdom is that you don't know. So it is better that you stay like a hungry and stay foolish over here, so that you should understand the critical components of quantum computer. So I believe in three motto principles, everybody, that knowledge is for the better word. So as a scientist, it is my responsibility that I should transmit the knowledge. Only when I'm transmitting the knowledge, I'm creating the better people, and better people means the better word I'm creating. So this is as a mission as a scientist. I'm working day and night from this mission from last 10 years. So the second thing is very important if you're stuck, especially for the PhD scholars and MTech scholars. If you're stuck in some problem and no one is supporting you, you need to relax, because God wants you to learn many, many things in the near future. And the most important thing for all of you, because we are in computer science, so imagine what was Google, what was Web 1.0, and imagine the world without artificial intelligence, and imagine the world with artificial intelligence, and the future is going to be the artificial super intelligence. So which means we have already started the journey of the agents and MCPs, and of course everything that is the agent control protocol and all those RAGs. So we should not be afraid of challenges and hardships, because the future is bright and technology is booming and changing like anything. So now I will be giving you some agenda in front of you. So I will be discussing what exactly is a quantum computer. I will be discussing about quantum computing and some machine learning algorithms, because right now if you talk to me that sir, we want to add artificial intelligence with quantum computer. So as of now, only machine learning algorithms can work, because still we are not in that high processing capability of quantum computer that we can integrate explainable AI, or of course with LLMs or deep learning. So after that, I will be talking about some quantum computing trends and outlook. And after that, I will be telling you some hidden websites. I can say some confidential websites that you can see that how you can be aware of the quantum computing things. You can even subscribe. And of course, I will be telling you how to have some online simulators. And after that, everybody, I will be giving you some demonstration in which I will be telling you one program code of Python. I will be telling you that code also. And in fact, you can even do the vibe coding also. And I will be giving you some live agent in which we will be covering with artificial intelligence that how we can perform our own quantum simulation like Shor and Groove's algorithm. So we will be going for all this thing, and you will be enjoying a lot with this lecture. So it doesn't matter where you start, everybody. The thing is, let's begin and let the journey begin of the quantum computer. So I hope you have all understood a brief profile of mine. And if you have any question regarding my profile or regarding anything about me, about my research, you are most welcome to keep your questions informed on the chat box, and nothing will be left over. Okay. So let's start the journey, everybody, in which I will be telling you, because as a start of this FDP on day one, I will not be discussing about quantum computing first. You should first of all understand what is a quantum computer, because remember, when we were old kids, we used to see that when we have to learn about computers, we have to learn about the components of computers. We still remember the day when my teacher used to tell me this is the input unit, this is the control unit, this is the ALU, and this is the output unit. And after that, we have to go in the lab and everything looks magical for us. So remember, everybody, quantum computer as of today is a magical device, but of course the applications that you can see as of modern world which are unsolvable, especially those algorithms like traveling salesman, the Hamiltonian cycles, drug discovery, and of course the validation of security, and of course the modern aspects of autonomous vehicles and smart cities, they are all answerable with quantum computer. So it is very important for all of you that before we study quantum computing, you should also study first of all what is the foundation of a quantum computer, how it came, who are the people, and of course what things you should understand in terms of the quantum computer. Okay, so everybody understand that I will be taking this lecture very easy. I have prepared very simple slides for all of you. So consider this as a course that you are actually here to lay the foundations, improve your knowledge, so that in the class, if anybody asks you that, sir, what exactly is quantum computer, how you can answer them. In fact, I will be also telling you, you just listen to my lecture very carefully. As a teacher, I always tell my students in FDP program that don't consider it as a technical lecture. Also consider it that how you will teach that subject in your near future. So with this lecture, you will also learn how to actually teach quantum computing in the class or in the future whenever any course comes over there. So everybody understand that quantum computer is not a difficult aspect to learn. You just have to be understanding some of the critical aspects in terms of photonics, physics, mechanics, mathematics, chemistry, and of course computer science. Then quantum computer or you can say the learning and research orientations of quantum computing becomes very normal and very simple for all of you. So let's start the journey, everybody. So in this presentation, I have already prepared 3 presentations for all of you for this FDP program. So let me see how much I can cover. But of course, I will be covering all the 3 presentations. So in this presentation, I will be giving you what exactly is called qubit versus bit. I hope you all know what is a bit. In fact, the modern computers or supercomputers or any edge computers or even cloud computers, they work on this principle of 1 and 0. Either it is on or either it is off. That's why we have these logic gates, the AND gate, OR gate, NOT gate, and NAND gates. But today, if you talk about qubit, it is having multiple qubits. It means quantum bits. It means many bits can be working at the same time. Okay, so I will be talking about the brief history of quantum computer. I will be talking about the trends and what's happening now, and I will be telling you with hands-on websites that how you can be really informed about this technology and how you can get the alerts, and if there is any breakthrough in your quantum computer, you will be immediately informed. So everybody understand what is qubit. So understand everybody, I will keep my lecture very simple, but understand quantum computing at the beginning is not very simple. You have to understand very carefully. If you miss any slide or if you are not with me, please understand you will not understand the next of the lectures of entire FDP. So it is my responsibility to create a basic of every foundation in a very clear sense. So remember, everybody understand, if you talk about modern electronics, whether you talk about your AC or your mouse or computers or even your televisions, they have 2 states. Either they are on or either they are off. That is called binary digit, 1 and 0. But remember everybody, if you talk about qubits, it has many possible states at the same time. It can be 101, it could be 001, it could be 111. So you can say as number of bits increase, like suppose if I made my 5 qubit computer, it can make 5 different possible states at the same time. So my dream is right now to build 76 qubits, which is already done, which means 76 possible states at the same time. But in the near future, if we can make 1000 qubits computer, it means number of qubits means number of possible states at the same time. So that's the reason you can see that it is equal to parallel computing. So there are 2 terms that are connected over here. One is superposition, which means that quantum qubit means that it can be having more than one state at the same time. And if you talk about entanglement, it means qubit can affect each other over huge distances. So which means you have to understand the concept of correlation. So understand, if you talk about quantum computer or the qubit, the 2 concepts are very important. One is superposition, which means multiple number of states, and entanglement, it means how much they can affect each other with huge distance. And that's the reason everybody, qubit can store infinite number of information. So the problem today of big data, the problem of artificial intelligence models, the problem of drug discovery, the problem of storage of information, or the problem of multiple, you can say, handling of instances at the same time. Like I'm driving an autonomous vehicle, we need to process tons of data at the same time. So that's my answer, that quantum computer is actually required. So the bottom line for this answer is that if you talk about those real-time applications where you need to process many tasks at the same time and supercomputer and mainframe are not capable as of today to handle them, quantum computer is the real answer. So the information can be extracted with the help of measurement, and when you measure the qubit collapses, it can result in less than 0 or less than 1, which means that the probability of alpha and beta, it is associated with quantum qubit latitude. So understand everybody, qubit means any number of possible states, and which means that the word is working on as many number of states means that you are actually having the capability to do as much of information as possible. So higher number of qubits means that the quantum computer becomes powerful. So it is same like that you have a laptop of 16 GB and now you upgrade to 32, then you upgrade to 64. But if you talk about qubits, it is increasing like anything. We started from 2-bit qubit computer with Google and Microsoft, and today the word is sitting on 800 to even 1100 qubits with China. But still the information is not clear because China is hidden. So you can see, everybody, if you talk about the quantum computing platform with only 3 qubit, which means that there are 3 types of multiple probabilities that can happen at one time. You can see 0, 0, 0, 0, 0, 1, 0, 1, 0. Now imagine, everybody, with mathematical model, if I'm making a computer of 76 qubits, how many possible states can be possible at the single time? And now in the future, if I make a quantum computer with 2 raised to power 256, imagine the possible states that can be happening. So all your mathematical problems, all your complex problems or algorithms that are not being solved as of today with computers, or you can say SHA 256 bit of blockchain, which is highly secure, it cannot be broken. So all those possible states of deciphering those algorithms can be solved with quantum computer. So if you talk about the classical state of computers today, everybody, we only follow the Moore's law. But now the Moore's law is not applicable because the technology is booming. And of course, the number of transistors and resistors have increased and doubled like anything. Because if you even talk about the gaming consoles or your smartphones or your tablets, and of course, your powerful desktop computers or gaming machines and video editing machines, and of course, the mining machines, they are very powerful these days. But if you talk about the quantum computer, it is offering a speed of quantum leap, which means today we are not connected like 8 plus 8, then 16 GB, then 16 plus 16, 32 GB. We are going like 2 raised to power 2, 16 raised to power 16, 32 raised to power 32. We are actually into the exponential level. We don't work on algebra in mathematics of computers in today's world. We are working with exponential level of quantum computers that we are having as of today. So if you talk about the real inventors, so you can take the photo of the slide and you can all read about the theory. So you can say that if you talk about quantum computer, in fact, till 2016, the quantum computing was actually theoretical. Some people even say that, sir, Google has made quantum computer before 2016, but remember, it was only a concept. It was not having any real applications. But remember, with quantum chips by Microsoft and Google and IBM, we have seen that the quantum leap of practicality of quantum computing, it started only 7 to 6 years before. So you can see that if you talk about the quantum theory, it was given by Max Planck in 1900, and after that you can see Albert Einstein. The whole world knows about it. So you can say the photoelectric effect. So Niels Bohr's atomic model. So if you talk about all the physics, all the chemistry, the atomic science, nuclear science, the algorithms, the mathematics. So if you talk to all the entire world that is happening as of today, we can say that quantum computer is having the bliss of everything. So if you talk to me today, that which is the area that incorporates anything, so it is industry 5.0. so what is the area that incorporates all the fundamentals of algos, computers, science, technology, everything? It is quantum computer. So you can say, if you talk about the wave particle duality, that was a major breakthrough by Louis D. And after that, I hope you if you have studied science and non-medical like physics, chemistry and maths, you must have seen this person with wave mechanics, where we have seen the possibilities, the probabilities for the possible results measured on the system. And that is the major foundation, that what kind of possibilities can be possible with number of qubits. So he was the man that actually laid the foundation, and we are today working on wave mechanics oriented principle. Of course, we have the photonics, but wave mechanics is basically the foundation. And after that, we should not forget about the uncertainty principle, where some properties of quantum object cannot be exactly shown at the same time. And that is what is happening, because still quantum computers are becoming stable, but they are still need to be researched out. So after that, I hope you can see this. These two are the principles that laid the foundation. And if you ask me, everybody, that who actually should be given the futuristic Nobel Prize, that this is the person. 1935 by Erwick, and you can see that the thought experiment of the cat. I hope you can see the experiment of the cat with the quantum superposition. What could be the quantum object at the same state? So if you talk about some of the movies like quantum, like we have the clock stoppers, we have the movie of the time machine, what kind of states that we can have, this is the answer. In fact, you can also search on Facebook. I have not brought that poster right in front of you. Now with the theoretics of wave mechanics and quantum physics and quantum photonics, and with quantum computer, theoretically time machine is possible. Theoretically, I am saying you openly, everybody, theoretically time machine is possible, and very soon it will be having the breakthrough. And I'm expecting that the first recurring time machine in which we can send a person back to 1940s, or we can send the person in the future to 2136, it will be possible by below 2045. So it is the answer that quantum can solve many possibilities that is actually becoming like a magic. So 1935, with the experiments, you can see with the intersection of particles, uncertainty principle means that unless measuring of one one particle instantly affects the others to prevent this accuracy. So you can say that quantum object can affect each other over long distance, and these are the two concepts where the foundation of quantum computing lays the answer, that is superposition and entanglement. That is the foundation. So if you talk about some of the other people, I hope you have seen this photo, and this is a very important photo where all the people who actually contributed for quantum computer and the quantum mechanics and even the wave mechanics, they're all in this photograph. So 1970, Charles Bennett, they did the phrase of quantum information theory. So you can say that it had already started 125 years before, but still it was still out of 125 years, 117 years were only theoretical and mathematics oriented. And if you talk about the quantum computer, this is the person, everybody, if you ask me who is the father of quantum computer, you can see the photo right now, 1980, Euro Manin. So this is how you should teach in the class. You should not give the name of the people, you should give the proper presentation, that how it started with the photo, and this is how the teaching becomes better. So he proposed the quantum computer in 1980 with his book Computable and Uncomputable. And after that, I hope you have seen the person Richard Feynman. So if you ask me today, everybody, that actually which is the first paper, or you can say like if you study the blockchain, then we all know Satoshi Nakamoto, and he is the member of and he invented Bitcoin, not the blockchain, and he write the white paper of Bitcoin. That's the fundamental paper of Bitcoin. But if you talk about the paper for quantum computing, so this is the answer. This is the marvelous paper that all of you should read. In fact, I can give you one homework today. Please read this paper and then start the next day FDP. This is the paper Quantum Theory, the Church-Turing Principle and the Universal Quantum Computer by David Deutsch. So this is one of the best papers that you can read in quantum computer as of today. And of course, we are talking about the Alan Turing principle and our computers, but we are over here, we are talking about the Church-Turing principle for quantum computers. So you can say 1993, where quantum information has led to the starting point of quantum algorithms. And at that time, we can see in 1994, the Shor algorithm. You can see the scientist also. You can see the photo. It's a rare photo and nobody presents the photos like this, but I'm doing it for you because this is a fundamental lecture. So you can say the Shor algorithm was basically the factoring a number into primitives. In fact, if you ask me that why quantum computer was invented, we need to calculate those calculations in fastest manner, which supercomputer takes months or even a years. And after that, I hope you can see that if you want to search the ultra fast data search, if you have the biggest database in the world and you want to search something, so this is the answer, that Grove's algorithm was there. So the answer today, if you ask me that, sir, the hyperledger or the blocks where they are linked together in blockchain and all the information, whatever the transaction gets authenticated by the miner, it is written over there. How I can search the blocks and how I can decode that information, then Grover answer is there. And of course, if you talk about the implementation of quantum computer, then David DiVenzo, he is the person who actually designed the scalable physical computer with a universal set of quantum gates and qubit orientation, and of course with the theoretical foundation of quantum error corrections. So I hope you can see these two people. And in fact, if you talk about Google claims that they were the first company to make the quantum computer. But in fact, these two people, that is Robert and Michael, they were the actual foundations who have actually laid a small quantum computer in just a simple garage. And they have worked on a circuit quantum electrodynamic. But I'm not a foundation student of physics because I was not a very good student of physics, but still I learn physics. I love to read mathematics. So if you talk about the fundamental concept which was adopted from IBM and Google, these were the two people who actually are the main inventors of quantum computer, where they are able to read the superconductivity, the coupling, and of course the electrodynamic. And after that, everybody, you can see that I was right. I have told you the answer. In 2016, the breakthrough happened when IBM actually made quantum computer over the cloud. And in fact, today you just search IBM quantum computer on the cloud. You can just log in, you can just register, and if you can spend like $57 with the taxation and everything, you can even access the quantum computer on the cloud, which I will be telling you later words, but just wait for that. So now, everybody, I would be giving you some information with regard to qubit platform technology. So understand that if you talk about the computing technology today, we all study about architecture, microprocessor, microcontrollers. So if you talk about the fundamental concept of quantum computer, you have to understand the entanglement, the superposition, and of course the qubit. So these are the three things that laid the foundation. And of course, we have the concept of electrocoupling and all those things. But of course, I will be taking you with the concepts one by one. So if you talk about the quantum qubit platform technology, it is all about trapped ions. So if you're a physics student, you can see that it is all about the chemistry and physics. So how this microwave and RF electrodes and with the cations over there, you can see the diagram right now. So we have the trapped ions. And of course, if you talk about the neutron atoms, we are talking about the quantum dots. But remember everybody, as of today, IBM is using niobium and aluminium on Si wafer based on Josephson junction. But you have to dive more because I'm not a chemistry student, so I cannot explain much of these chemicals and all those things. So you have to explore more that how they react and how this chemical reaction is actually happening. But remember, if you talk about the quantum physics and quantum mechanics, this is a very complicated subject. So you can see, if you talk about the first quantum dots, the real photo of quantum dots in the world, this is the photo that you can see on the left hand side. So you can take the photo and you can even put it on the chat GPT and you can get more information about that. And you can see the SIP and you can see the NV in diamond. So you can say that we have the laser excitement and unpolarized single photonic emission. So all the concept of quantum computer or quantum photonics, it is based on photonics only. So you can see everybody, as of 2024, you can see that if you talk about the expectations of Gartner, still quantum computer is still a theoretical concept, but it has moved up, which means that we are getting the simulators, we are getting the algorithms, we are getting the books, we are getting the breakthroughs in qubits by China, by Harvard, by of course by Stanford University, and of course by some of the universities in Europe. So even in UK, my one of the friend is in Lancaster. They also have the very powerful you can say powerful quantum computer, and they are working with Newton fund of about like $6.7 million. And they have, and of course, after that, I'm also having with the Chungbuk National University. But of course, if you talk about the quantum computer, everything is becoming scalable, everything is becoming hyperly connected. So if you talk about the future, all the visions that if you want to set up the high end, you can say smart city and autonomous vehicles and smart hospitals of the future with the live data, blockchain, and of course the deep learning getting trained with the live patients and everything with x-rays and all those things, then quantum computer is the answer. So you can say that still it is below, but still it is becoming better and better, that you can see by 2027. This is my expectation. Now this is with artificial intelligence, that quantum computer will be actually above digital twin. So digital twin is a technology that right now, after cyber physical systems, industries are crazy about it. And right now NVIDIA is doing digital twins projects with the hospitals and even with labor camps and all those things. But in fact, by 2027, digital twins and all your medical technology will be below quantum computer, and quantum computer will be taking over them. And this is what we are expecting with quantum computer by 2033. So 5 to 10 years, you can see that quantum computing will be among the top 10 in the world, which is right now among top 15 in the world as of today. So you can see that these are the top strategic technologies that you can see in terms of intelligence, in terms of digital and mesh. So if you talk about all those technologies that can be bothered, and of course, if you want that all the technology should be having the brain of advanced computer, the answer is quantum computer. So if you talk about some of the flagship conferences and everything, now I will be giving you some more information because the foundation has done. So I will be giving you some more information so that you can be informed. So right now, if you ask me that, sir, I want to take some funding and I'm an Indian, I'm a Chinese, I'm a Taiwanese, I'm from Vietnam, I'm from Japan or Korea. So where I should find the flagship projects, or where I can find some project-based funding. So this is the answer, that European quantum flagship is the movement which is actually started from last 5 years, and they are actually funding lots of projects. This is one of the area that you should see, and you should regularly open this website, and you can see that how they can you can say collaborate with the researchers and industry together. Right now, Google and Microsoft and of course NVIDIA, they are investing billions of dollars in this flagship. And after that, you can see these are the technical quantum milestones. In 3 years, we will have the quantum processors with more than 50 qubits. Now, I'm not talking about quantum computers, quantum processors. And of course, in 6 years, the quantum processors will be fixed with robust qubits, which means that we can scale them to the raised to power n, or of course n minus 1, depends on that. But in 10 years, everybody, the quantum algorithms will demonstrate the quantum speed up and all your processing of artificial intelligence. I can say that your chat GPT, your Facebook, your Google, and of course your AI based tools today of video gen like Kling, or of course like image gen tools like DALI 3, or even you can talk about Flux. All these will be running with quantum. So which means that the photo and video that you generate of only 5 to 10 seconds, and the photo takes about 1 to 2 minutes to generate, depending on the prompt, it will just take 1 millisecond. So that's my answer, that the search of Google as of today will be the same of the future of AI in terms of generation and regeneration. So if you talk about the quantum simulators, we have seen technical milestones, and of course in 6 years we will see that the algorithms that are actually unsolvable in science, like quantum magnesium or quantum annealing, that will be answerable. In fact, I'm the person from Swarm Intelligence. Still, I have the barriers that we cannot simulate more than this type of natural based insects and birds, or even the monkeys and all those things in the quantum simulator. But everything will be possible, where I can make a real monkey based animal, and I can make that algorithm, and we can perform that is the spider monkey algorithm that can be simulated with more than 1,000 monkeys. And let's see how they can integrate with the routing process for IoT. So as of today, as a computer hacker and of course as a researcher in healthcare, I'm only working to crack the SHA-2 256-bit, and secondly, I'm working on healthcare informatics to train the models, especially for breast cancer, the brain tumor, and of course with the segmentation of paralysis and autism. So in next 10 years, the proton type quantum simulations will be possible, so we can be able to even simulate quantum chemistry. So remember everybody, your all physics and chemistry are part of quantum, so you have to learn many things. So these are the technical milestones as of today that you can see in terms of QRNG and QKT devices. And in the next 10 years, we will have the development of autonomous metro era, and of course the development of quantum internet, which I will be discussing in the trend in the near future. Just wait for that. But of course, in terms of quantum sensors, we are expecting major breakthroughs in terms of camera lenses, the telescopes, and of course, if you talk about the satellites of the future, like we have the Voyager that will complete the 1 light year in September 2026. We can even have the quantum telescopes, like we have the Voyagers and all those things, and we can see about 100 light years that whether the alien life is possible or not. But you can say that if you talk about 10 years, your iPhones, your Samsung phones will have to be commercial devices that will be quantum phones. So we are expecting quantum phones even by year 2035. And this is answer everybody, that if you talk about the quantonation, this is a very good area that you can do your research, you can take the photo, and they are also having lots of investments and companies come, and they are also designing new products in terms of security for quantum encryption. So as a person of, because I'm a computer hacker and I do math based security, so if you search my papers, I do quantum algorithm, quantum cryptography only for cloud and for IoT. You can see my papers, my all papers are getting above 30 plus citations on every of quantum. And very soon my quantum book will be available, but it is a secret I will not open right now. So this is the CATS everybody, where the QKD devices and RNG devices on photonics that can be implemented. So if you can go to this website called cats-quantum.com, you can see that UK, Bristol University and Lancaster, they are working very nicely in this, and they are able to enable lots of agile quantum safe communication. So the future of your wireless communication, that will not be with radio signals, it will be with the laser and maybe with quantum photonics. That's the future, that maybe you can even able to download maybe one locality, only one, maybe for even say a city of 25 kilometers, only one quantum antenna is possible. Rest the quantum phones can perform the work, and you can even stream like YouTube, like anything. Maybe you can stream 8K live on Instagram in the near future. So this is about, you can say, the QSide, one of the best project that you can see for securing the hyper connected society. So you can note down you can take the photo of the screen and you can note down all the slides. But of course, I will be giving you some hands-on at the end of the lecture. So this is China everybody. So if you ask me that, sir, which country has the best quantum computer as of today, I will be telling you the name of the countries at the end when we open the websites. So right now China is making one of the best quantum computer, and I'm having my next visit in China to Chinese Normal University in Shenzhen, where I will be getting the chance to collaborate with them for the next level quantum computer, maybe above 1500 qubits by next year. So this is Australia, where you can see the UNSW Laser Lab, the quantum computing lab at University of Queensland and Australian National University. And this is what you can see in terms of Quintescent Labs, where you can see that if you are really working on quantum encryptions, or of course, if you talk about the quantum wallet, the soft wallet or the hard wallet of cryptocurrency, when you talk about the NFT tokens and NFT marketplaces, or of course, the future is DeFi finance, that is a decentralized finance. This company is actually collaborating cryptography, quantum technology, and blockchain together. So this is Silicon Quantum Computing. So you can open this, and milestones are already getting up, but you can see. And in fact, if you want to do some internship in terms of quantum, this is one of the companies that you can do some online internship. And this is USA National Quantum Initiative, and very soon we can expect the IEEE standard also for quantum technology. And in terms of quantum image sensor, you can see that we have the single photonic sensitivity at room temperature. And you can see some potential applications that I'm expecting is that very soon Canon and Nikon can even have the quantum photonic chip in their cameras. And you can see that if you talk about the DSLR cameras today or the iPhone camera, which is like 48 megapixel, very soon we can have the camera which will be like gigapixel, maybe like 2 gigapixel. So you can say that you can take a optical photo about like 50 kilometers away from your iPhone in the near future. That could be the quantum image sensor that can be possible. So this is about the Intel, the first quantum computer by Intel by 49 qubits, and now they have upgraded it to 861. So you can say that more and more superconductivity structure or RF connectors, and of course like the graphene structures they are working on this type of thing. But of course, if you're into meta materials, this is one of the best areas where the people are required to make some new surfaces and meta materials. And this is IBM Q, the first working prototype in 2016. And this is what you can say in terms of the traditional computers as compared to quantum computers, where you can say that single wires are crossing temperature gradient, where you have seen our quantum computer also, where we have put the optical fibers, and of course it controls the microwave signal gating and qubit measurement. But as compared to classical computers, we are not using any thermal cooling, we are using the cryostats, that is a cryogen technology. And these are some of the algorithms that you can see in terms of applications. But of course, I will be opening some applications. So quantum algorithms, quantum chip, and of course, the algorithms in terms of control electronics and autonomous vehicles, some AI-based algorithms for healthcare, the drug discovery. This all can be possible with quantum. And this is what you can say, one of the IBM based experience by quantumexperience.org. That is a blue mix. This is one of the simulator that you can try. But of course, I will be telling you how to make an agent today, and we will make our own simulator like quantum, so you can make it. And this is what are the top simulators, if you ask me. That is the Qiskit. And of course, everybody, you can see I have copied some code for you, and all the coding is based on Python. So if you ask me today that, sir, what we should learn as a language to learn quantum computing, this is only Python language. And this is D-Wave technology, one of the persons that are working on 128 qubit, but now they are working on 1024 qubit computer by 2025. And this is all about the CPUs and GPUs that we have today. But in the future, we will not have the CPU and GPU or APU. We will have the QPU, that is a quantum processing unit. Now, I'm very excited that maybe in my near future, my laptop will not have the Intel Core processor or AMD Radeon or AMD Ryzen processor. I will be having the IBM, maybe the QPC, or maybe the NVIDIA QPC in my system, maybe like running at 1 to 12 terahertz, maybe more than that. So you can say we have the softwares that we can perform, and of course we can do the optimization in terms of social network analysis, sentiment analysis, portfolio, and of course if you talk about the fintech and of course the applications for healthcare, these are the top applications that you can perform with quantum computers. And this is Google AI, and I hope nothing needless to say that they started with 9 qubits, and of course today Google has made a breakthrough with 500 plus qubits. And this is the Zendu, and this is Ragiti. And you can see this is one of the founding companies, and they hold over maximum patents in the world after Google, that is with the quantum programming structure and of course with quantum deployment with the multi-photonic structures. And this is the company that I would like to show in front of you, that is a Quantum Circuits. So if you want to research more that how exactly quantum computers are booming, what are the new algorithms, and if you have your own algorithm in your mind, you can give them and they can test and validate your algorithm with their own quantum circuits. So you can say, everybody, will it practically work? The question is that we can exploit possible quantum states, but concern is number of qubits, the error rates, and of course the measurement between the distances. So that's why the entanglement is one of the crucial structure that we are working, and transpositions. So you can say, if you talk about the outlook of quantum computing, this is one of the best articles that you can see. So 1000 to 100,000 logical qubits for practical quantum computer can be achieved in next 5 to 6 years. So many more works are related to hardware, software, and algorithms, and plus the funding support is required to make a useful quantum computer. But the problem today is, everybody, that quantum computing lab is very tough. Of course, it is very expensive, because my lab that is collaborated with Chungbuk, it is costing like right now 3 to 3.76 million US dollars, but we have the plan to enhance it to $10 million in next 3 years, but we have to struggle a lot. So this was all about your introduction towards quantum. So now the house is open for next 2 minutes for all of you. If you have any questions or you want to ask any question on chat box, you are most welcome. Madam, can you please enable the chat, please? Hello, coordinator ma'am? Hello? Hello? Anybody hearing? Hello? Hello? Hello?
Sir, you are audible, sir.
Ma'am, please reply. So I was asking you that please enable the chat box.
Yes, sir.
So that if there is any question to the people right now regarding the quantum computer that they have seen, and of course with the foundations of quantum computer and some fundamentals of quantum computer, they can ask me the question for 2 minutes, and after that we will start with the quantum computing and the quantum machine learning algorithms.
Yes, sir. Yes, sir. Sir, actually it's enabled. I request participants, if you have any question, you can put in chat
So
window.
if they want to ask or interact with me for 2 minutes, they can even unmute themselves. They have 2
Sure,
minutes.
sir. Sure, sir. Sure. Okay.
It should be interactive.
Sir, I have one question, sir. Like if
Yes, of course,
quantum
please go ahead.
computing will be the future, what will be like happen to, sir, classical computing? It will be exist or it will be like vanished fully, like just if you will see that now AI is replacing all the thing. So we are like quite like what will be
I give you
our
one example, madam. I give you one example. So if you talk about your television today in your home, I think so that even today, if you go to some of the shops and local shops, like local electronic shops, and you say that I want a CRT television, I hope you can get it. But of course, do you want to buy the CRT television in 2025?
correct.
That's my question. So that's my answer to you, that if you are not willing to buy the CRT technology because you know that LED is better, QLED is better, mini LED is coming, and they are becoming cheaper. So why you want to buy the CRT television? So if in the future, if you are affording, because remember, madam, at one time you will be shocked to know, at one time 8 GB RAM system was costing 1 lakh rupees, and today you can even buy in 1 lakh rupees, that is a 32 GB to 64 GB, and even expandable to 128 GB system in 1.5 lakhs. So it all depends on you, that what is your budget, that if in the future quantum computer becomes cheaper, they are better, and you are having the budget to buy the quantum computer, you can buy that. But of course, slowly and slowly, they will be replacing all your existing traditional computers like CPU, GPUs, and all your thermal cooling. So computers will be different.
Yes, sir.
So that's my answer to you.
Correct.
Okay, so I think so, one person has given me hello on chat box, that is Harsha. So please go ahead.
I am having one query.
Yes, please.
Sir, as you mentioned regarding European quantum flagship,
Yes.
so my question was that how we can interact with those projects if we
Okay.
want to share our practical sessions or the knowledge being provided on these website, and we how can interact to this
Okay.
flagship
Okay.
project.
Got it. Ma'am, the first thing is that if you talk about these flagships and all those things, then you have to understand that they always have a proper tech team. Okay, they're having proper tech team, and of course they open the proposals, because some of the proposals, no doubt, they will be from European nations only. But if you talk about European nations, like suppose today if you talk about Korea, so we have lots of projects like Korea Vietnam project, Korea Indo project, Indo China project, Indo Australian project. So you have to keep an eye that what kind of projects they have, and what kind of professors are working with their labs. And after that, you have to write an email that, sir, like suppose today you want to write an email to me that, sir, I'm a MTech student, I have done my research in quantum and I published these papers, I have seen your publication, so can you please tell me that how can I collaborate? So if I'm having the project, if I'm having the funding, I can interact with you, I can call you for an interview, we can have some Zoom meeting, and of course this is what we can say that. But if you approach that, okay, you are an Indian passport holder, you approach directly to EU computing platforms, it is not possible. You have to go with a ladder of a person who is sitting in Europe and he has the project, and then you can apply the project as a technical consultant. Okay, like suppose today if you talk about my project of quantum, we actually Chumbuk University, they approached me that, sir, we have seen your research, can you help us to make the quantum? So I told them that, okay, I can design your fiber optics, I can design your computers, I can make the quantum computer working, so you have to send the money. So now I'm involved and they are giving me the money to upgrade it. So it all depends at how you're getting recognized.
Okay, sir. Thank you,
But
sir.
one more
Thank
thing,
you, sir.
but one more thing, which I would like to show to you, which I will be showing you at the end. If you go to this website, madam, that is this one, Australian Research Council. Now see this, madam. Now many people don't know about this website. This is the website, madam. So please keep an eye, because if you really want to go to Australia and New Zealand, so they open the projects. This is open for whole of the planet. And very soon they will be opening up projects in 3 areas. One is big data, second is artificial intelligence, and third is quantum. So you can make some proposal and you can submit. And if you get the proposal approved, trust me, you can even become associate professor. You can even get the citizenship of Australia. So that's a hidden news that I can give it to you.
Okay, sir. I got it, sir.
Got it? Thank you so much.
Yes.
So I'm having
Sir.
one more minute, everybody. Then
Sir,
I will be starting with the presentation.
Sir, one question is
Yes.
there.
Yeah,
Someone is-
I'm coming to that question by Sandhya Arora. That is quantum computing helping in healthcare research? Of course it is helping, madam, because if you want to train those models, which can take like a month or even 3-4 months, like brain tumor or breast cancer based research, I can train those models with quantum computer. Like if you talk about my quantum computer, 76 qubits, I can even train about 20 billion photos or x-rays in just a matter of 3 days. So that's my answer. So of course in drug discovery, we can do that. So that's my answer for that is called your in terms of healthcare research. But of course, I will be taking more questions at the end of this
Sir,
one.
One more
Yes, please.
question. One more
Of
question
course,
is
of course,
from
I will take. So what are the
participants.
security challenges in quantum
Yes.
area? In fact, there is no security challenge. Quantum computer cannot be hacked. In fact, quantum computer can be used to hack blockchain. So that is like a biggest hacking computer. So if you have a quantum computer based work style, and if you put all your government data or everything, trust me, the hackers are unable to solve that. In fact, we are actually using quantum computer because as a computer hacker, I'm using quantum computer to hack the blocks based information. That is a cipher based information, which is SHA-2, 256-bit, which is impossible for modern computers to crack. This is where we are working.
About to ask the same question only, sir.
Yes.
So nowadays hackers are more involved using quantum computing to hack all.
No. Let me stop you. Let me tell you, till date, even as a DEF CON person, I will not tell you what I do in DEF CON, but you can understand that if I'm saying DEF CON, I'm a very important person in security. You can see my security actually. So as a DEF CON person, and even as a cyber security consultant, and as a penetration tester, even as a live forensic person with more than 10 projects with the government, trust me, no hacker has right now the full control of quantum computer. Right now, they don't have. So I have not seen anything.
Okay,
They're
that's
doing
a
it
good
for
news.
research only. Yeah, hello?
Thank you, sir. Thank you.
Yeah. So ma'am, let us continue with the lecture. Thank you so much.
Yes, sir. Yes, sir.
So everyone, I hope you are all enjoying. You have seen that what exactly is the foundation level of quantum computer. I've shared you all the scientists, and even have showed you how to style your teaching in the near future. If you are doing anything in the near future with regard to teaching, you should follow this type of instances so that you can become an effective teacher for quantum, and of course any other subject that you can teach. And of course I've already given you that you need to study about quantum chemistry, quantum physics, photonics, and you need to learn about mathematics, and of course the transposition, entanglement, superposition. I've explained to you very detailed in terms of qubits, and you understand that today if you increase the number of qubits, you increase the number of possible states. More number of possible state means that the quantum computer is becoming future and better and more you can say scalable in terms to handle complex problems. And very soon, everybody, in the near future, what we are expecting that only Microsoft is making the quantum processors. In the very future, we can have the CPU and GPU that can be replaced with quantum processing units. So that was the lecture number 1. So I hope everybody has got the idea, but of course in next 5 days you will have more detailed ideas, more high-end information about quantum. But of course you are most welcome to write an email, or even I will be giving you my WhatsApp number at the end of the lecture. You are most welcome to collaborate with me. Okay. So everybody understand, if you talk about quantum computing now, so what is quantum computing? We are building up systems. We are building with the foundations, with processors, the cryogen, with the number of qubits, and we are using it for real-time applications. So you can see, everybody understand that if you talk about quantum computer, there is no quantum word. There is no quantum word. It is only an abstract physical description. So it is just about the task of physics, how the nature is all about. So we can say that quantum physics is, we can say that quantum computer is just to simulate the quantum physics. So quantum computing is a magic, and quantum machine learning can improve that magic. So if you ask me that, sir, how we can train the models, how we are able to, you can say, use it for healthcare, use it for security and everything, this is all quantum machine learning. So right now we are working on 3 algorithms. One is random forest, support vector machines, and XGBoost. So these are the 3 algorithms we are working, and very soon I will be integrating KNN, and in the near future, of course, it will be going to SHAP. Of course, we want to go with BERT. Of course, we want to take it to LLMs. It depends on the future. So I will be talking about the major players. Now you will see that how the presentation should be made. So like I'm doing the presentation, make it more visual. And I hope everybody have seen one important thing. I'm not making any boring presentation, no theoretical. It is all practical, and it is all focused on real-time examples. So this is how you should give the lecture, so that lecture becomes interesting. So I will be talking about in this lecture, everybody, what is quantum computing, the foundations like qubits and everything. And then I will be talking about quantum machine learning, the concepts, applications, and major players. And then I will wind up this lecture with the trends, and then we go to some hands-on. So everybody, if you talk about quantum computing and quantum machine learning, now see how I have created the presentation. Now see how beautifully it is created. So quantum mechanics. So what is quantum mechanics? Quantum mechanics means it's a science that is dealing with the behavior to understand the matter and the light at atomic and subatomic level. I hope you have already seen that movie Ant-Man. So what he was doing, that actually he was turning his main physics. He is actually training the main physics to become subatomic. Like we can make the person very small. So what I'm doing, it is all about atoms. So I'm just playing with the atoms, and I'm becoming subatomic. So if anybody has not seen that movie, please watch that movie Ant-Man. If you really want to work about quantum mechanics, the quantum, and of course quantum realm. So you have to work on that. So it is all about the foundation of all quantum physics, quantum theory, quantum technology, and quantum information scale. In fact, if you talk to me, sir, what exactly is quantum? That cannot be measured. It is actually about exploring number of possible states, and there is always the principle of uncertainty. Like in chemistry, we always say there is an assumption and there is an assumption to the assumptions. So it is all abstract. So what is computation? What is quantum computation? Which means all the study of information processing tasks that can be done with quantum mechanical systems. So I'm designing a quantum mechanical system with quantum photonics, which we have number of quantum qubits, quantum bits. And of course, we are able to accomplish tons of information that today's classical and of course modern computers like mainframe or Mac Pro, or of course, if you design a 8K video editing or a gaming system, that is not possible. So quantum machine learning, which means that you can apply the quantum machine learning algorithms and you can integrate with quantum computers. So they are much faster. They can break the passwords. They work on qubits, like multiple Qs, zeros and one at the same time. And quantum machines use virtually no electricity. In fact, the billing of quantum computer is almost very less. So still date, you can say that it will take about like 10 to 20 years more that we can achieve some quantum realm. So these are some of the quantum devices and machines that can be possible. So if you talk about the hardware, you have the sensors, which I've already told you, the quantum image sensor and the quantum optical sensor. We can even talk about quantum vision systems. So imagine if I have a drone which has the quantum processor and quantum image sensor. Imagine the photos and imagine the decisions it can take at the real time. So if you talk about autonomous technology, if it wants to be perfected, so the quantum technology is the answer. So quantum information system, quantum cryptography, I hope everybody knows about QKD. And you can see my papers right now. Quantum cryptography I have applied in 2 applications. One is cloud computing, and second is we are working on IoT. And third is quantum computers and quantum inspired systems. So after that, you also have the quantum simulators, which I've already told you. I will show you practically. If you just type best quantum simulators, you can install everything like on Google Colab or even on Anaconda. And they're all the quantum simulators. The biggest advantage is that all quantum simulators are free. There is nothing to be paid. In fact, they're just like a package, like you install NumPy or TensorFlow on Python. So it is same like that, which I will show you practically. Just wait. So this is one of the pre-knowledge that you should acquire, everybody. Now this is very important slide for you. So what is quantum computing? You need to learn about the subset of quantum mechanics. So with regard to linear algebra, probability, statistics, quantum hardware in terms of calibration, error management. And if you talk about data science, you should know about the optimization techniques, machine learning, and of course, calculus. So you can say it is more like a subject of mathematics and physics and little bit of computer science, and then it becomes like a quantum machine learning. And these are till now, everybody, I can say that till 2024, we have the data. So this is right now the exact data that you can see. So right now, if you talk about the highest investment in the world by any by any country is China. So if you talk about the drones, the electronics, the robotics, if you talk about the autonomous flying vehicles, the quantum computers, it is all with China. So if you ask me today, na everybody, that sir, I want to visit a country where I can change my personality, I can change my behavior, I can have a new thinking. Just go to China, go to Shenzhen, go to Xiong, and go to Xi'an, and go to Chongqing. So these are the 3 cities that you should visit in China, and trust me, your vision will automatically change. So these are the major players, and you can see that right now the major player at the top level is IBM. Of course, the best quantum computer is with China, which I will show you in the websites. And after that, it is with Google and Microsoft. And of course, right now, if you talk about Amazon, you can even do quantum machine learning on Amazon on cloud, Azure, and Google Cloud. So right now, if you talk about the simulators, then IBM Qiskit. So this is the major simulator. Nobody knows that it is a simulator from IBM only. But of course, it has lots of assumptions. So this is now quantum computing and quantum machine learning in depth for you. So I've already told you, everybody, now this you can take the photo. Now I will not talk about basic things. I will talk about advanced things. So what is qubit? So single qubit, it means it's a device representing quantum information, which means information that has no boundaries. It is still infinite. It cannot be measured at a particular sense. So Q states could be depending on the probability amplitudes. And of course, it can be the number divided by numbers like alpha, beta, gamma, whatever it is. And when measured, the qubit collapses into the states that is less than 0 and less than 1, which can be observed with probability amplitudes. And this is the multiple qubits, and the things become more complicated now. It depends on the 2 states, depends on superposition and computational basis. So you can say that noise can even occur, errors can even occur. So remember, when qubits are entanglement, the measurements are highly correlated. That's why we are very careful. Even if in the next 2 years I'm able to gather my computer to 300 qubits, I see that I'm lucky. I'm able to make it a stable computer, because remember, error correction or error reduction is the biggest challenge to do research practically in quantum computer, because quantum circuits are actually little bit unstable. And this is the example that you can see in terms of the algorithm and programming, which I've already designed for you, which I will show you at the end of this lecture. And in fact, I will give you that code you can run, and you can learn more about superposition and quantum states. Of course, I don't know who is the person. Xiaomi Redmi Note 9, he has raised the hand. I'll come back to you just after the lecture. So you can say, everybody, like we have resistors, capacitors in CPU and motherboards. We have the quantum resistors initialized to greater than 0, and we have the quantum state space, which means 2 raised to power number of qubits. That's the reason I'm telling you, we are not working on algebra in computers today. We are working on exponentials in the future. And that's the reason, if you talk about the quantum circuit design, we need to prepare the quantum information. We have to process that quantum information, and we need to measure the qubits to obtain classical information about their state. So these are some of the quantum applications. So many people were asking me what we should do and what are the applications we can do the research. This is my answer to all of you: cyber security, fintech, material manufacturing, transportation, of course, smart autonomous system, logistics, energy, drug discovery, biotech, and of course sensors. So this is where we are doing our research. My area of research is number 1. You can see in the front of the mouse, cyber security. I am working to crack the SHA2. We are working on healthcare and drug discovery. You can see one of my book in Wiley, and right now I'm writing 2 and 3 chapters and 1 or 2 books of quantum with Elsevier and CRC Press. Very soon it will be discovered, and of course it will be working on case studies right now. So in terms of the quantum machine learning, you can see that we have the quantum resistors, and we prepare the input as a data set. That's a training data set, and we are having the processor or processing of the circuit with parameterized gate, and the output could be 1 or 0. So it depends on the number of states. But remember, the quantum machine learning, they combine quantum computing and ML together. So that's my answer for all of you. But the only thing is that the algorithm is still not yet optimized. We have to take the base algorithm. But of course, if you want to tune your own quantum machine learning algorithm, you need to follow some states with regard to quantum bits. And these are some of the algorithms that you can take. You can take the photo and you can discuss that what exactly you want to study. But right now we are only working on SVM, we are working on random forest, we are working on linear algebra. But after that, if you talk about neural nets, the GANs, still it is very complicated. So I'm not working on that, but very soon I will be working on quantum teleportation and quantum image processing. So we can work that how we can generate some images in better form and of course in quick manner. So all the answers that are slow in the world of today in classical computers, they will be faster with quantum computers. And these are the answers, everybody, that if you ask me that, sir, what are the risks and benefits that are associated with QC and QML? So the answer is there in front of you. So if you talk about the risks that are associated with quantum tech, the threats for new algorithms, because still it is very costly. And of course, the reduced entry cost, higher entry cost for the businesses, lack of knowledge, shortage of expertise, but very important is storage of development methods, which is based on the NISQ devices, because all the devices should be NISQ. But remember, they can solve very fast equations. They are very energy efficient, but still in terms of implementation and cost, it is very costly. And these are the opportunities that you can perform your research. So you can apply for QC and QML applications. And of course, you can create some quantum software engineering methodology based things. And you can study some 3D visualization and data science, and especially AI, especially when we talk about video and image generation using quantum computing. And these are some of the appendix of history that you can see at your end. So with this, I would like to wind up this lecture also. And now I will give you 2 more minutes. If you have any question, you can ask me the question, please. So Miss Pratima Panigri, she has given me the question. Thanks, sir. Very nice session. Thank you so much for your feedback. Can't speak, but have a QSN regarding autism, as you said. How can quantum computing will be implemented for early detection of kids that may be helpful for diagnosis? So as I've already told you, that very soon there will be a combined data sets. Like suppose I'm having a hospital in Vietnam, you have the hospital in India, they will be all sharing the combined data on that data sets. Now that type of data set will be like a quantum breakthrough in types of data processing. So in order to process that data and train that model, that whether your data or in the future can be quickly predicted, you need a quantum computer. So the answer is that if you want to have the quantum level of data, the exponential level of data, which today's modern computers take like training time of more than like 6 months or maybe 8 months, that can be done in 1 day or maybe few hours. That's my answer. Yes, anyone has any question before I start with the final lecture?
So there's one question from a participants. They are asking, he's asking whether we can go back to the time using quantum computers.
Madam, I have already told you that actually, just wait. Let me check with my photo if I have that photo right now. If I have the photo. No, I don't have the photo right now. Otherwise, I would have shared that photo. Just wait. Okay. If you can see my phone, madam, can you see the phone can you see my phone on the screen?
Yes, sir.
I hope this is my answer to all of you. Quantum breakthrough enables scientists to reverse the flow of the time. And it is the latest article by August 5, just 1 month before. It is possible now. Theoretically, it is possible. Because the quantum time travel is just like rewinding the time. You can go behind the time, but of course, I have already told you that the only thing that right now it is not available to mankind. In fact, invisibility is also available now. But invisibility is on the medium level, still it is achieved. But if you talk about the only one invention that mankind is only seen in the movies, that is a time travel. So quantum time travel will be possible by the end of, you can say 2035 or 2040, but we have to still wait for next 15 years. But quantum photonics is possible.
Thank you, sir.
Okay. Yeah, any other question? You have 1 minute, then I will start with the last lecture. And that is going to break your knowledge in terms of quantum communication, that what will be the trends and outlook, and then we will go only for the hands-on, the practical demonstration. Excuse me, coordinator ma'am.
Yes, sir.
Is anybody coming who is demonstrating with regard to quantum circuits?
No, sir.
Okay, actually that type of lecture you need actually. But no problem, actually I'm a little bit busy, but maybe next time I can give some hands-on simulation with quantum circuits, but I have prepared one agent for all of you that how you can prepare some quantum circuits with that, which I will tell you at the end of the lecture.
Sir, we have kept one session for that, but let's see whether they will teach hands-on or not.
But that
We have
depends,
already
madam,
kept
because
this.
quantum circuit session is very difficult. Only few people know about it. But anyways, no problem. Maybe next time I will do some hands-on with quantum circuits and quantum cryptography. Maybe I can prepare that. Okay, one more minute, everybody. If anybody wants to give some feedback on the chat box, or if anybody wants to ask a question, you are most welcome. But I will be giving you some websites where all this information like quantum time travel, what is happening with quantum phones, what Google is doing, what Microsoft is doing, everything will be clear to you. You can all subscribe. Everything is free. And every day you will get the alerts for quantum. Okay, I have prepared all the things. Just wait for this lecture, which I will not take much time, only 15 minutes. After that, only hands-on. Okay, please hurry up, everybody. Only few seconds more for you for the window. After that, we go to the next knowledge.
Sir, one faculty
Dr.
has
Prabhu
asked.
A is giving me the question, what are the basic knowledges required to start from the scratch? So that's a very good question. So the first answer is for you that you have to know some fundamentals of programming, like in terms of logic building and algorithms. Of course, you need the design and analysis of algorithm, which people miss. Second, you should be a good programmer in terms of Java. And of course, the language that we have to use in quantum is Python. And after that, you need to study about quantum physics, little bit about chemistry. You need to learn about mathematics. And after that, you need to learn the depths of qubits and of course the quantum physics. And then after that, you can start with quantum computing. So it has taken me about 5 years to make my own quantum computer. And we failed about if you talk to me that, sir, have you made it for the first time? No. It took me about 17 times we have failed in order to start that computer. So now we have started and we are upgrading. So it requires millions of dollars of investments of research, which I don't think so in India is possible.
Sir, may I ask a doubt, sir?
Yes, please. Go ahead,
You
please.
told me you are working on cybersecurity.
Yes.
Are you working with AES algorithm, sir? If so, what is the key level
Sir,
you
you
are
will
working?
be actually, sir. Actually, it's not a cyber security lecture, but I will request Miss Taskeen that she can arrange some hacking lecture for me, or maybe cyber security lecture for me. In fact, I would like to tell you something about me. I have already cracked SHA2. I have already cracked SSH. I have already cracked AES also, that is up to 128 bit. And now I'm researching on to crack, that is the complete blockchain. So if you talk about the real, because blockchain is what? It is a hyper ledger. You can even see the blocks. In fact, the first block of Satoshi Nakamoto, you can even see. So what is my answer is that we are ready to take that Merkle tree in terms of a hyper ledger. And in that entries, we will be opening that blocks, that who was the sender, who was the receiver, what was the transaction, and what is the atomic wallet number, like the wallet numbers. So we have to crack that type of thing. This is where we are working.
Okay, sir. Okay, sir.
Yeah, we are working on that. But in terms of security in the future, my dream is to make a firewall that is like a quantum, which I will be telling you right now. That is a quantum internet. That because even today, can you give me one answer that what is the most popular protocol of internet? How the internet works? Which protocol is used? And 90% people say TCP/IP. It is not. If you talk about the routing protocol, which protocol we use in internet? Can you tell me, sir? Anybody can tell me?
I know about TCP/IP only, sir.
No, now that is the question, sir, because actually you need to work on the depth of that, because I'm a Cisco certified. In fact, I have already cleared my CCIE. So let me tell you, if you talk about the internet, it is not only the TCP/IP protocol, it is actually the BGP protocol, border gateway protocol, which is actually routing your traffic from here to there. Because today, if you type google.com, you are actually routing your information from one router to another and another, and it is unsecured protocol. And that's the reason if you talk about Google and Microsoft, they work in their demilitarized zones. They have their own protocols which are being constructed in their own data centers. But remember, internet is actually very complicated P2P network. But in order to secure the internet in the future, we need to redesign the internet, that is Web 4.0. In that Web 4.0, that will be quantum protocol, in which we will be working on quantum internet, and that will be quantum control protocol, QCP protocol. This is where we are working. We are researching on that, in which we can say that we can even integrate Web 3.0 and we can even partially integrate Web 4.0, the migration from one sector to another sector. You got it, sir?
Yes, sir. Yes, sir. Thanks for clearing, sir.
So remember, if you are teaching networking, so understand most of the people, what they do, they just cover routers, switches and gateways, and after that LAN card, and then they go to TCP/IP. But in fact, most of the people don't focus on domains, the subdomains, the regions, and of course the controllers, and of course how these protocols are actually working. So you have to work on the routing protocols. Then you have to work on the control protocols. Okay. So now there is a question from Amit Mishra. After this question, I will be starting with my lecture. Good evening, sir. Good evening. Really impressive lecture. Thank you so much. My question is that which company has yet designed quantum processors? I've already told you this is the company, and I can show you the company right now. Let me show you right now. That is the, if you talk about Microsoft quantum processor, that is the quantum processor over here. So you can go to this website, everybody, that is called the Majorama chip. So this is the answer. This is called the, and this is the processor that you can see. Can you see my screen, sir, everybody? Can you see the screen? Hello?
Yes,
Can
sir.
you see
Yes, sir.
my screen?
Yes, sir.
So everybody, if you ask me that which is the first quantum processor, it is Microsoft. That is the Majorama one. Now I hope you can just check it over here. Please mute yourself. Thank you. So I've given you this link right now, everybody. So please check the Majorama processor, and you can see that the person who invented Majorama, he's actually an Indian, Chetan Nayak. But I hope you already know that we Indians are very creative, but we already know what is happening in the politics of USA right now with the current president, what is happening with the jobs now. But remember, we Indians have the best brains to perform those things. Okay, so you can see it is just an answer. So it's about your own quantum hardware, and very soon your computers will be based on this chip, everybody. This is your next Intel processor. Like today, if you want to assemble your computer, you have Intel processor, Core i3, i7, i9, or Intel Core systems, or AMD Ryzen processor. This is the future of quantum. This is the quantum processor, QPC. Okay, so that's my answer to you, how we can work on it. Thank you. So, madam, I am starting with the final lecture. Okay, ma'am?
Yes, sir.
Thank you so much. I hope everybody is enjoying and the feedback is good at your end. Okay. But of course, you can take the feedback of every lecture and you can discuss with that. Okay. So, everyone, now I will be discussing the most important part for today. In fact, I will be discussing a little bit about quantum internet. What exactly will be the quantum internet, where only your routers and switches and Wi-Fi's will be based on your processing chips. It will be based on quantum chips in the future. Okay, and the speed that I'm talking about the quantum internet is will be more than about like right. Can anybody tell me right now that what exactly is the highest speed, and which is the country that has the highest speed right now? What is the highest speed of internet in which country, and what is the speed? Please be informed for all these things. Can anybody type on chat box? Japan, very good. What is the speed? What is the speed? If you can give me the speed, but don't search on the internet. The speed which I would like to tell you, it is practically possible. It is 1.8 terabytes per second, which means you can download the entire internet in 1 minute. Now, if I'm downloading a movie like from Netflix, I hope you can see Netflix also. But one thing I would like to show in front of you, how many people believe that Netflix is paid only? How many people believe? Yes or no? Madam, I would like to give you some little bit detailed information.
Yes, sir. Yes, sir. Sir, I think you are muted.
Anand sir, I think you are not audible.
Can you hear me?
Yes, sir. Yes, sir.
Okay. Thank you. So, sir, I hope everybody knows that this is Netflix. And if you want to open Netflix, you all have to pay the money. Yes or no? Everybody agrees? Yes or no? Yes or no? Agree?
Yes,
Okay.
yes,
Yes,
Now I
yes.
tell you one website, everybody. I tell you one website. In fact, I can hack anything. So I tell you one website. You don't have to pay anything to Netflix. You can go to this website, everybody. Just search on internet. This is called Moonflix. And if you go to this Moonflix right now, you can see that you can watch all the movies and anime and even everything like Netflix. And it is free. And you can watch everything in Hindi and even in southern languages also. Free. In fact, I can tell you also how you can make YouTube Premium free, how you can make Spotify free. I can hack anything. Hacking is in my blood. So you can see that, everybody. So you can see all the movies that whatever you want to play right now. It is same like Netflix, but it is free. And even, of course, do this task. Take this website as a browser. And after that, you can make your own app. You can make your free Netflix app on your Android phones and iPhones. I don't pay anything. That's my answer. Hope this is the answer, everybody. That how we can do that. Okay. So let's come to the business of quantum communication. But of course, I will be giving you more tips and tricks if anybody wants to see what exactly could be the AI and everything. But if I have the time, I will open some websites for you with regard to AI, and I will prove it to you that all your images and videos can be free of cost, everything. Okay. So everybody, let's talk about the quantum communication, the trends and outlook. So you can say that if you talk about the landscape right now, this is the landscape in front of you where we have the three categories, that is security, networks, and services. That's my answer. The security is all about your quantum cryptography. Network is all about your quantum internet, and quantum services in terms of that how you can work with regard to your own healthcare. You can work on simulations. You can work everything. And of course, if you talk about the commercialization, NST is working, and the market size is in front of you. It can even reach up to $14.9 billion by 2035. But if Majorama 2 comes in a small size, and if you talk about companies like ROG or MSI, they make the motherboard that is quantum motherboard and can produce that quantum chip. Trust me, 50% of the future quantum desktop computer is ready. That's my answer. That at one time we used to have the 486 systems, the Pentium 1 or Pentium 2, that we will have the first system in terms of the Pentium 1, the first quantum computer. So if you talk about the quantum computing, everybody, we are talking about the technology foundations in terms of qubits, the platform infrastructure, and of course the customer requirements. And of course, this is the Q day when we say that we can able to crack all the encryption algorithms. And of course, we have already cracked with post-quantum cryptography, but the only algorithm that cannot be cracked right now, that is the two algorithms. One is the RSA and second is the SHA-2. So we are working to crack SHA-2, but we are not interested for much of RSA, because if we are able to crack AES, then RSA is easy to crack. So this is my answer, everybody, for all of you in terms of communication development, how we can provide secure communications, scaling and connecting quantum computers, and we can have distributed computing and sensing in terms of quantum networks. So this is a very good area to perform research. In fact, I would like all of you to please research what is about the content distribution network today, content distribution network, and how you can make the quantum distribution network. That could be a review paper, and that would be excellent research that you can perform, and easily 5.6 impact factor of Elsevier will take your paper. So this is quantum internet, everybody. This is the quantum networks, which means networks will be able to transmit quantum information. Now remember, internet or today's communication. Now, right now I'm sitting in Vietnam and you can see my video. I can hear your voice. It is all with data packets, but in the future, it will be photonics. So which means that the future will not be the packet-based network, it will be photonic-based network. So you can say that it is enabling technology, but still they have to be added up with quantum hardware. We have to add quantum encryption, and we have to leverage entanglement, because the problem is the range and we have to correct the error codes. That's why today in networking, we have the network error code correction. So same in quantum network, we need to work with a quantum error code. You can say the corrections also. So this is your answer for all of you, that how this network is going to be. That is a quantum network. That here you have the network node, here you have the routing cable, then we have the communication channel, that is the optical fiber network. We have the quantum repeater, quantum switches, and everything will not be on data packets, it will be on photonics. So remember, everybody, if you talk about the quantum repeater, it is all about entanglement between the qubits. So if you want to boost these qubits, you need the entanglement. That's the reason we have these repeaters in the network, to boost the signals and to transmit it to long range. So same, the problem will be in the repeaters. We have to check the range of the photonics. And this is how you can see in terms of the post-entanglement communication. So what is quantum entanglement, everybody? I repeat again, an essential features, because you need to know that the quantum state changes and they cannot be described independently. So to make sure that you swap the entanglement, we need to make sure that the memories of quantum assist in the swapping, because otherwise there will be lots of errors in terms of transmission, and the packet will be, and the photonics will be disrupted. And this is what you can say in terms of quantum key distribution, the leverage principle of quantum physics. And of course, it is theoretically proven secure, but practically quantum cryptography, I have not seen, except 6 to 7 people like me, they are working on certain protocols. In fact, I have designed my own protocol, that is the QEKDD protocol for quantum for cloud computing, and QIX1 protocol for IoT networks. You can see my Google Scholar, you can search them on Elsevier. Both of them are on 6 impact factor. So in terms of assessments, everybody, we can see that quantum communication and quantum computing, you can see the companies right now. Cisco is working, IonQ is working, Quantum is working, QNera, and of course, IBM. And I would like to give you some breakthrough in terms of this one, everybody. Now read this. I will not repeat for you. This is what you can take the photo, that how to present the graphs and table in front of the students. So you can say in terms of quantum security, we can work on QKD. In terms of quantum networks, we can work on quantum global internet. And in terms of services, in the future, we will have the quantum information services like quantum antennas, quantum 6G, or maybe quantum 7G. And of course, we will have the quantum radio receiver and transmitters also. And if you talk about the maturity level, everybody, you can see right now only Europe, United States, China, and of course in Asia Pacific, we have very little investment. So right now, if you talk about China, they are actually building the quantum satellite also, which is going to be the military satellite for them. And this is the answer for everybody, that how this market is totally addressable. The only 3 things are required. One is quantum communication, quantum computing, and quantum sensing. So the company that is working over there, they have the full control, like artificial intelligence of the future. And 2-3 things which I would like to share with you. Only one thing. Okay, everybody. So you can see, everybody, in terms of synergies and key differences, what is quantum computing and quantum communication. So quantum computing, we have the quantum control. And in terms of quantum communication, we can see that we have the efficient interfaces for readouts. And if you talk about quantum computing, we have the high compute performance, and we have the provably secure cryptographic systems. And this is going to be the last slide for all of you, that this is the Q day, everybody. So right now you can see that we are in 2025. But if you talk about 2026, you can see that this is the possible day when RSA 2048, the only encryption that we believe that can be cracked only by the aliens, will be cracked by quantum attack. So remember, everybody, if I'm having a quantum computer, I'm actually launching an attack. So quantum attack will be possible. And of course, by 2029, I'm expecting that we are able to successfully crack the SHA to 256-bit. So that's my answer for all of you. And that will be my presentation. And now, if you have any question, you can ask me. But before you start the questions, I would like to open some hands-on for all of you. Now, the first website for all of you, everybody, I will be putting everything on chat box. So I will be opening, you can open the chat box right now. So everybody, this is the website, everybody, that if you really want to know what exactly is quantum computer, what exactly the researchers are working, what about the quantum error correction, what about the quantum brush, what about the quantum algorithms, what exactly will be the quantum book list, the quantum computing future. This is the best website that you can see. And of course, you can subscribe your email here and you can get all the information every time, everywhere. So this is my first website to all of you. Now, the second website for all of you, if you really want to analyze what exactly is quantum computing, what is doing, what exactly is the report, what exactly is the investment, you can see all the analysis, news, players, resources, everything is available on this website. This is called quantumcomputingreport.com. Now, this is the second website for the day. In fact, you can even go for membership also. You can even apply for Quantum Society membership, which very soon will be open for common people by IEEE also. Now, the third website, everybody, you can play this type of quantum game. You can design your own quantum circuits. So if you ask me that, sir, is quantum circuit difficult? No, it is not difficult. You just have to design the circuit like a network, and you have everything in terms of photonics. You have the quantum filter, you have the quantum repeater. You can even design your own quantum network also. And you can even play quantum game also. That what exactly in terms of inference, entanglement, and varia you can play. So everything is in front of you. You can form in terms of the non-polarizing beam filter. So I'm giving you this website, everybody. You can play some quantum games also. Now, the next website is for the best thing that you can understand. This is the quantum computing playground. If you really want to understand that how to simply start with quantum, how to work with Shor, how to work with Groove's algorithm, how to get some programming, how to get some examples in terms of syntax, quantum gates, everything is available on this website. You don't have to install anything. Everything is based on simulation and Python based, and you can work over it. This is called the quantum playground. Now, the next website for all of you is called the Quantum Insider. Now, this is the website where if you really want to know what exactly is the future of quantum landscape, what exactly the companies are doing, what exactly is the research, the project works, everything that is available, it can be tackled on this website, Quantum Insider. Next website is available on your chat box right now. Now, my personal favorite website, everybody, this is called QBlocks, in which you can see the documentation, the white papers. In fact, all the information for quantum latest information is available here.
There are any replies?
So
that we know the form is working fine.
Sir, please mute yourself. Thank you, please. So this is the answer, everybody, that QBlocks information that you can see. Okay. So now I would like to give you the list of the quantum projects, that how on GitHub you can see what kind of projects you can do, and you can do your research also. So go to this website, everybody, qosf.org, which I'm going to give you right now. And here is a project list. So you can see what kind of project list is available. And even you can see the quantum simulators also. In fact, Intel quantum simulators available. And you can even see, if you come down, you can even see all the projects with regard to quantum annealing, quantum algorithms, and you can even see the codes of quantum compilers also. Everything is available on this website. Everything. So if you ask me that, sir, I want to have this information, I want to have that information with regard to quantum, it is all available on this website. Everything. So now, everybody, I would like to open with all of you that how you can get more information about the post with regard to quantum. So this is the best article that you can study, the top 10 quantum best computers in the world. So as of today, you can see the Jiuzhang, the Chinese computer is there. After that, it is Zhendu. Then you can see it is IonQ, which I've already told you the website also. And you can even see the Rigetti Advantage. And after that, Intel Horse Ridge 2. This is one of the most popular quantum computing chip that is available. And you can see the D-Wave Advantage also. So this is the website you should open, and you can see some of the most important services also. If you want to work about your iPhone development, you want to work with regard to tutorials, VTech is one of the best websites and platforms. Now, this is the answer, everybody, that what exactly we can do in terms of collaboration. So Eureka, this is the website, and you can see what kind of projects are working right now in terms across the world. So you can see Netherlands. You can even see what exactly are the references, what exactly are the other investments by different governments. Everything is available on this website. The top website, in fact, this website is almost secret. Now, everybody, I have already prepared one website for one agent for you. So you can all go to this website called GenSpark. I'm giving you this website on this chat box. So you can see I have prepared one prompt only, make a complete agent of deploying all quantum computing algorithms. And it has prepared all the things in front of me. And here is the agent that I have created. So you can see on the right hand side, I am able to create the quantum circuit builder, and I'm able to even simulate the live quantum search algorithm. So if I just click on run quantum algorithm, you can even see the live demonstration over here, and you can see the rate of quantum vectors with regard to alpha and beta. So you can make your own agent. You can define your own agent. You can even get all the things that I have prepared. In fact, I'm sharing this link to you. I've already prepared this agent for you. You can use this agent free of cost. And the second thing which I would like to show in front of you already, everybody. Now, this is the coding that I have already prepared for you. So you just have to install, that is the QUT IP. So this is actually a quantum based library for Python. And you can see I have prepared another programming code that you can demonstrate the superposition, entanglement, and even I have already prepared the Detsa-Joza algorithm. And you can see the results in front of you. So I'm copying this code for you, everybody. I'm copying this code. Just wait. And I share this Word file to you on your chat box. I'm not able to share maybe. Anyways, I give it to the coordinator. She will give it to you. Okay. So now everybody, I'm going to open 2-3 websites for you so that you can become a little bit expert in artificial intelligence. Now, what if I tell you everybody that you all have to take ChatGPT subscription, you all have to take Gemini subscription, you all have to take Grok subscription. So what if I tell you that you can use everything free of cost? You don't have to pay for ChatGPT, you don't have to pay anything. And above all, you can use everything free, unlimited. No boundaries, nothing. So what you can do, go to this website called LM Arena, everybody, lmarena.ai. So go here. And after that, you just have to do one thing, and you will be shocked to see this website. It's an AI website. You don't even have to log in also. So just go to lmarena.ai, and after that, you just have to click on Battle and click on Direct Chat. And after that, you can see all the models are available. And you just have to click on ChatGPT 5. So if I just say, explain quantum computing like a child of 6 years. And you can just see that I will get the answer. Unlimited answers you can prepare. There is no limit. There is no payment. Unlimited, you can see all the models are available. In fact, you can even see the Gemini 2.5, Claude 3.7, DeepSeek. And even if you come down, you will be able to see that you can even see Gemini 3N also, the latest models. All the models are free here. So it can generate the information for you, and you can see that information is coming in front of me. So if you really want to see that how you can work with quantum computer, this is the answer. So just explain quantum circuits like a child of 6 years. So if you want a humanized information, let me show you. Like you just say /human. Now the information that will be generated, it will be humanized manner. It will not be directed by Turnitin also. So see, explain quantum computing and traditional computers difference in form of table. So now the table will be generated, and the information that I will be generating, it is in pure humanized form. So still it generates. I will give you one more website. There is an AI for that.com. Now see this, everybody, we all have a confusion that if we want to make our voice over, we want to make avatar, we want to make ebook, we want to go for AI plaque scan, we want to generate images, video, what kind of AI we can use. So just go to this one, everybody. This is the answer. I open the website again. So I'm copying this website for you. There is an AI for that on your chat box. And I also copy LM Arena. Okay, so you can use it, and you can see, everybody, that if you want to generate images, if you want to get some information with regard to the trending things, you want to search some tool with regard to the deals, with regard to mini tools, you want to have some free AI, you want to have some tarot-based AI, everything is available. You just have to search. Like if I want to search with regard to resume builder, and I press enter. So it will automatically tell you that what exactly is the AI resume builder tool that you can use. In fact, it will also tell you that there is another tool called ResTune. You can get Bench. You can even get AI resume builder for recruiters, resume build, workup. So you can get all the tools that you want to have. So more than 1 million tools are available as a chat, as a Google for that. Okay. So this is what you can do. And you can see that table is in front of you. And I'm again telling you, in LM Arena, there is no restriction, nothing. So with this, I would like to wind up my lecture. I hope you have enjoyed the practical, the hands-on, the agent, the quantum computer, the quantum computing, the quantum machine learning, and the trends, and of course the future, what exactly is. Now you have 5 to 10 minutes more, whatever the time is, you can fire the questions and I will be more than happy to support you. And of course, everybody, if you search on this one, that is quantum computing simulators, just press enter. You will be happy to know that there are more than 63 simulators that are available, and all simulators are free of cost. So I'm giving you this link also. You will get all the information of all the simulators here. So all simulators are open source. You can see all the links are also available. Everything is available. So you can use GenSpark also for making the agents. Yes. Any questions now? House is open for next 5 to 10 minutes. Any question? Most welcome. You can talk to the inventor of quantum computer right now. Yes, what I should elaborate, Ms. Shruti? Please elaborate. Okay, so you can see everybody. Again, I'm recommending just go to this website called lmarena.ai. Just click over there, and after that, click on Battle, click on Direct Chat, and after that, you can see the models. So any model you can use. In fact, you can even use the Amazon Nova experiment. You can even go downstairs. You can even see the DeepSeek version 3.1, which is even not available right now on DeepSeek also. So everything is available.
Thank you, sir. I think there is no question. So thanks a lot, sir, for such a wonderful session. And this
Excuse me, sir. Sir, how do we need to implement to the simulator code which is being provided in the Word document?
You just have to go to this website called Google Colab. And just paste the code. Just run this two things which I've already given to you. Okay, just copy the code here. Just copy this one, install, and after that, just copy the code and play this. You can even see all the demonstration of superposition, entanglement, and you can even see the demonstration of Detzel-Josa algorithm. After that, you can play with some of the states also. Because right now I'm working on only 12 qubit states.
Sir, this can be done with the help of Jupyter Notebook also.
Yeah, Jupyter Notebook. Yeah, Jupyter Notebook Anaconda. You just have to install this package first of all. The pip install QUTIP. That's all.
Yes.
Sir, there's one question from Dr. Kamal Raj. He's asking, can we use them in Python code through IM Arena?
I don't understand, madam, what you want to say.
Sir, he's asking whether he can use them in Python.
LM Arena.
LM Arena, sir, he's asking, can he use with the Python code?
What Python code? I don't understand. You want to generate Python code here?
No, he want to use, sir. He want to use that with Python code.
What Python code, madam? I don't understand. I have already given this code right now. This is a Python code.
The AI, the LLMs.
Sir, I have already opened. What exactly you want? Give me the specific. I'm not able to understand your question. Hello?
Sir,
Hello?
actually, sir, he want to know whether he can use them in Python code through LM Arena. If he has to do the coding using Python, can he do through LM Arena? That is
Yeah. I'm showing you right. You can see. Generate Python code for performing all matrix operations. Enter. That's all.
Okay, sir. Got it.
In fact, there is also one more website, code.dev. Text to app. Make a tic-tac-toe game. Immediately, I will make something. So maybe it is paused right now, but I will show you the code right now that will be generated in vibe coding. But if you ask me, madam, that if you want to generate the best coding over there, then the answer is Gemini 3, or of course you can generate with DeepSeek also. ChatGPT sometimes make mistakes because if you talk about this code, I made this code myself. So you can see this type of code. This is a perfect structure with regard to Python and all those things. So let me generate one code for you. You can generate everything. In fact, you can even generate images also. Yeah, you can even generate images also with the LM Arena. LM Arena is fully free. You don't have to take any subscription. So you can see everybody that right now I have told you how you can take all the AI models free, how you can take Netflix free. So in fact, I can even teach you how you can make Spotify, how you can make YouTube free. In fact, madam, you will be happy to know I'm using my smart television. I'm using Apple TV. My Apple TV Pro subscription is already hacked. I don't pay anything. In fact, my entire smart home is free. In fact, I live in a smart home. Everything is free here.
Good, sir. Good, sir.
As a cracker, we do lots of things. In fact, my office is smart office today. I'm right now it is like 10 o'clock in Vietnam, so I cannot show you my office, but my office is a smart office.
Sir, if
So
there
it
will
will
be
take
any,
time.
if there will be any further questions, sir, we will send you, sir.
Sure, but just
Because,
the coding will take a little bit
because
time.
speaker
So
2 is also like waiting for his session.
sure, no problem.
If you will.
No problem. I hope you can use. So there is one question which I would like to take. How can quantum optimize IoT networks for smart cities? So I've already told you that IoT networks generate plethora of data. And of course, if you talk about the smart city, when we talk about autonomous vehicle or autonomous like drones and all those things, we have to control and we have to make real-time decisions. And for that type of real-time decisions, we sometimes need the 5G, but of course we need a high-end smart neural network. So in terms of that neural network, rather than to put the supercomputers or like NVIDIA A6000 or even Lady Lovelace based GPUs, you can put the quantum computer that can be a quantum leap of information. Okay, so you can see everybody, the Python code is getting generated. So this is the Python code. You can see it is already going to cover abstract plus. And in fact, you can see, madam, it is also going to cover linear algebra, inverse decomposition, solvers, and even extra also. So you can see a beautiful Python code is getting generated. And you can see the perfect structure is getting generated. So everything is getting generated. Little bit it is slow, but trust me, LM Arena is fully free and you can copy all the things. In fact, you can make agents right now. So genspark.ai have already told that how, in fact, for this lecture, I prepared an agent of quantum computing. So you can see right now, decompositions are also there and the perfect structure is generating. Man, just let us generate this code. Just only 1 minute.
Sure, sir. No problem,
you can see even that all the code is getting generated and you can just copy paste the code on your Anaconda, or you can place the code on your cursor or anything, whatever you want to do, or even you can go for notebook LLM. Maybe in the future, madam, ask me ask some lectures for me for hands-on AI. Then
Sure,
I will
sir.
tell what exactly is called a lecture. Hands-on AI.
Correct.
In
Sure,
fact,
sir.
that lecture will not be PPT, it will be full practical lecture.
Sure, sir. Sure.
Full 100% practical, in which I will even teach you that you can even make your own song and how you can even control your computer with some models that some people say that Claude is there, but Claude we have to pay $200. In fact, let me tell you, madam, that there is a new browser called the Comet browser. Now this Comet browser is costing $200, but I have not paid it. In fact, you can see it is working beautifully in my computer. Now this is an AI browser that you can see how it is working. I actually literally hacked this Comet. So you can see, sir, that the entire Python code is getting generated with all the operations and it has given you all the details that what exactly is going to be coded up. So in less than 1 minute, we have solved all the things with regard to matrix operations and we are using the NumPy based Python module. So you want to change this code to Java, JavaScript, C++, J#, it depends on you. Thank you.
Thank you, sir.
Hope you all enjoyed. Thank you.
Yes, sir. Thanks.
Yeah,
Doctor.
I'm giving my contact information, madam. Just wait. So everybody just search me on Google. This is my search. And here is my website. LinkedIn, you can contact me on my LinkedIn. And of course, this is my email ID. Anybody can email me and go for collaboration. Let me give you my personal email ID also. And here is my WhatsApp number. Only WhatsApp. Most welcome to collaborate. Thank you, ma'am. Thank you for inviting.
Thank you, sir. Thanks, Dr. Anand, sir, for such a wonderful session. This session provided a foundational understanding of quantum computing, qubit technology, the evolution of quantum computers, and future of quantum computing with applications of quantum machine learning and quantum communication, trends and technology by highlighting its key principles such as superposition, entanglement, and quantum gates, by emphasizing the motivation behind this emerging technology, addressing the limitations of classical computing, and unlocking new possibilities for solving complex problems. Although still in its early stages, quantum computing holds immense potential to transform industries ranging from cryptography to material science. Moving forward, continued research, learning, and practical experimentation are essential to harness the full power of quantum technologies and drive innovation. Thank you once again, Anand sir. Now it is my privilege to welcome Mr. Robin Kumar Yeshumani for delivering FDP session number 2 on quantum bits and quantum states. Mr. Robin Kumar Yeshumani is manager at BMW TechWorks India. He is responsible for cloud operations team that supports Apache Kafka client in Kubernetes service deployed in Azure and Amazon cloud rooms. He has over a decade of experience in roles at companies like Accenture, IBM, Cognizant Technology Solutions. I request Mr. Robin Kumar sir to kindly come and deliver the session 2 of FDP.
Excuse me, Tansin, now I have to leave because I have another meeting in the morning. So it's already 10 o'clock in Vietnam. Okay. Thank you so much.
So, Anand sir, I just have one question. I'm
Yes,
sorry
please.
for interrupting because I was just experimenting. I just tried with your suggested AI tool for writing a code in a Python just to
Yes.
extract the character from the list, which consisting of a tuple set dictionary, and the code is too heavy because the same code I tried it. The chat GPT cannot generate, and I'm really appreciating the tool LM Arena you have suggested, but it is too complex, I feel. So,
Madam, then that's what I've told you, that if you want to generate the code, it depends on model to model. So it is my request to you that if you want to generate a very lighter code and everything, you have to experiment. You have to generate the code with Gemini. You have to generate the code with Grok 4, DeepSeek, and then you have to see which code is okay, good to understand, clean code, and little bit lighter. That's why I'm telling you, you have to experiment with the models.
Okay.
Yeah,
Okay.
so
I could
don't
able
only
to do
generate.
it generated
Yeah.
because I have written
So
the
don't.
same
And
solution.
remember, madam, I'm not training you today for AI. In fact, let me tell you, everything depends on the prompt also. So you can go to this website called Prompt Genie or Prompt Optimizer, and you try to make the best prompt that what exactly you want. And then you have to reuse that prompt in Gemini, in Grok, or even in DeepSeek. And then you have to generate the code and then validate and retest the code, what exactly you want.
Okay, sir.
It all depends on models to model. Thank you.
Thank you, sir.
Thank you so much. Thank you. Okay. All the best.
Thank you. Thanks, sir.
I request Robin sir. Please unmute and deliver the session, sir.
Okay, hope I'm audible now.
Sir, you are audible, sir.
Okay, thank you. Shall I go ahead? Hello, everyone. Okay. Madam, hope I'm audible to everyone.
Sir, you are audible, sir.
Yes.
All right. Thank you so much for your response. And it was a great privilege to participate in such a wide audience and energetic people. And already it's a long session with a fantastic session with scientist Anand Nair. And so I'm not going to take most of you. So I'm just going to explain. very fundamental basic things about the quantum bits and the quantum states today. It's going to be a very simple session, and you can easily understand. And with I have very live examples, you can easily understand from there. And at the end of the session, probably you can ask any questions if you have. So just a brief introduction about me. Currently, so I am myself Robin Kumar. You can find me on LinkedIn. And yeah, so I have around 15 years of experience in IT industry. So ma'am already explained about my past experience. Don't want to jump into that again. So I would like to directly jump into the session. Okay, I'll start with some basics of the quantum bits and the quantum states. Yeah. May I share my screen now? Hope I have permission. Yes. Okay, let me start presentation before I start. Okay. Okay. All right. Please let me know once my screen is visible to everyone.
Yes, sir.
Thank you.
Yes, sir.
So today agenda will be the quantum bits and the quantum states, types and the comparisons. So what kind of quantum bits are there, and what are the different types of quantum states, and so what are the main applications about the qubits and quantum states, how it is differ from the regular bit, and what is the big advantages, what are the current challenges we have at this present moment, as Mr. Anand sir explained. So now, and also challenges, I'll touch a few challenges what currently we have, and finally I'll summarize the points we already discussed, and we'll have one small quiz session where you also can participate online. Keep your mobiles ready to scan the QR and join the quiz. And finally, we'll have a time left for the questions and answers. So let's get started. Here, the classical bit versus the quantum bit. Okay, the classical bit is just two information, whether it is a 0 or 1. And it's a static information. Okay, you can store 0 or you can store 1. Okay, it's a basic unit of the current computer. Now it's already became a classical, although it is still, we are living in the current computer era, but it's already a classical, which means quantum computer is growing really, really faster. So very soon we will be experiencing, in fact, we'll be enjoying the quantum computers. So now, so if you think about a decade ago, so the mobile phones they were like a brick size and the size of kg. Probably the current generation people may not experienced it, but we really experienced from the very first version of mobile phones. Now you see the size of the mobile phone, it's a far improved. Similarly, the quantum computer, now the size may be huge, but when the science grows, when the quantum computer grows, so the size will be all automatically going to reduce, and it will be on your palm size. It will be on your palm, the quantum computer. So now the qubit is about, it's it will have both 0 and 1 at the same time until the final result is finalized. If you see the quantum bit, okay, it can exist either 0 or 1. Okay, this state is called a superposition of both. Okay, so it's like, let me give you a small example about what is the yeah. If you see, the classical bit is about just turning on a switch on or off, but the qubit is spinning a coin on the sky. Okay, this coin it may have heads or it may have tiles, and another thing is using the quantum bit or a qubit, you can spin a number of coin at the same time, and the results also can be measured simultaneously or parallelly. That's the beauty of the quantum bit. So here it's just a quick example about it. Okay, so I'm going to jump into a little boring thing, about the mathematical representation of the quantum bit. So please make a note of this. It will be very helpful as you are getting started, as you're starting with the quantum computing career. If you see, this is the mathematical representation of the quantum computing, where the cubic state written as, it's usually we say ket, okay, ket psi equal to this alpha, probability of alpha plus probability of beta. And if you see there's a new character, okay, this is called as a ket. Ket is probability. Okay, so it's a probability. Alpha and beta are the probability of the amplitudes and complex numbers, you mean. And this one, the probability of alpha square is the probability of qubit being in state 0, and the probability of beta square is probability of qubit being in state 1. So this is just a quick mathematical representation of the qubit. Probably you can make a note that will be helpful for the future. Now, when we say qubit, okay, so we want to just experience it, right? Okay, I'm going to give you a small example about what is a qubit. If you see, 1 qubit means you have possibilities of 0 and 1. And 2 qubit means you have possibilities of 4, which means 2 to the power 2. And you can see 0, 0, 0, 1, 0, 1, 0, and 1, 1. These are the possibilities. And when you say 3 qubit, okay, you have 8 possibilities, which means it is 2 to the power 3. So now the sir discussed about, right, in the previous session, he mentioned about 2 to the 76 qubit. He already developed it, which means 2 to the power 76 possible units. So the number is really huge. And in fact, Google already developed 500 qubit, and the future is 1,000 and more. Okay, so this is just to give you a simple example to understand what is the qubit and what is the representation of 1, 2, 3 qubit. There people are discussing about it. Now you can easily understand with this. And let me just dive a little deeper into that. Okay, the basic states of 3 qubits. Okay, each qubit can be 0 or 1. For 3 qubits, there are 2 to the power of 3, which it has 8 possible basic states. So you can see I just written for your understanding. And these are like a binary numbers from 0 to 7. Okay, we can write the binary number 0, 0. So here it is the values. This is 0, this is 1, and this value is 2, and this value is 2 plus 3, 2 plus 1, 3. So similarly, it goes up to 7. Okay, this is the basic of this one, the superposition, and this is a general state. Next, I'm going to give you the general state of the superposition. So a 3 cubic system can be a superposition of all 8 states. Okay, where this the alpha I and the beta is a complex probability and the amplitude. Okay, this I gave you a small representation so for your better understanding. So this is how the quantum computer will make it as equation of this qubits. Then let's take a simple equal superposition of all 3 qubits. Okay, so this means the system has equal probability of 1 of 8 of collapsing to any of the 8 basic states when measured. So here here you see it has the 3 qubit means it have all 8 possibilities, and 8 possibilities can hold data of 8 different levels. And you can, which means each qubit, each one you can run through you can have 8 different possibilities, and you can compare all 8 different possibilities at the same time, and this is called the parallelism. So I'm going to discuss about I will just summarize about the key properties in the qubits. That's something very important to understand. So the key properties are the superposition. The superposition is in the current computer. Okay, the classical computer, when we say bit, it can hold either 0 or 1, and it is static. Okay, it won't change. If you store 0, the value will be 0. If you store 1, the value will be 1. But in the qubits, the value can be measured at the end. So it can hold multiple state at once, and the qubit can exist in a mix of both a 0 and 1 until measurement. Until measurement means end result. Okay, until the end result is reached, it will try all the possibilities, and it will be ready with your results. And this superposition actually enables the parallel processing. So when you say parallel processing, okay, so in your mobile phone, you are opening multiple applications at the same time. Your WhatsApp, your mobile phone dialer, or your contacts, or your Gmail, and some games at the background. Okay, some high-end phones can hold all the applications running at the same time, which is a parallel processing. But few phones which has a small, very less configuration may not able to hold everything. So that is a parallel processing, which means this superposition enables quantum computer to perform the parallel processing. That's important key for that. And the next one is entanglement. So this is something really interesting. Just imagine you just triggered a processing, okay, and if there are it is, for example, 5 qubits. Okay, if it is a 5 qubits, and every single 5 qubit means 2 to the power of 5. All right, and so it will be 8, 64, 256, and 512. Okay, so it will have 512 parallel. And imagine if all 512 parallel processing is able to communicate each other, which means a single processing, a single qubit can communicate to all the remaining 511 qubits interchangeably. So that is possible using the entanglement. So this connection is happening using the quantum computer, they are saying it is a magic connection. Okay, so currently it is, for your easy understanding, there is a magic connection between, one and other qubits interchangeably. It is not a one-way communication, it's a two-way communication, and they are tightly coupled, they are tightly connected. And during the parallel process, I'm going to show you a better image, then I will explain in detail. All right, so here correlation between the qubits, a special correlation between 2 or more qubits, and measuring 1 qubit affects the state of other even at a distance, which means the 500th, okay, or 510th processing, okay, so that result may affect the first qubit, which means they are interconnected. Let's take an example. Our brain, our entire body is connected through nerve system. And if your toe is hurt, how do you get the immediate attention to your brain? Because it is it's interconnected. So all the parts of body, all our body it's a great networking, and it is interconnected similarly. So all the qubits are interconnected during the processing. And that's called the entanglement. That's an important key property of a qubit. And remember, such entanglement you don't find in the classical bits. Next, the interference. So it amplifies the correct solutions, and the quantum states can interfere to amplify correct outcomes and cancel the wrong ones. So this interference means if the qubit, if it is doing according to the expected results, it will continue to do it, and it will allow to achieve the result quickly. If one of the qubits is not doing in the expected way, and it will immediately cancel it, and it won't let the qubit to continue its operation. So that's called interference. And so in the previous lecture, you would have heard about the error correction. So the error correction is very important so that you will get the optimum and accurate result for any research or any analysis. So this interference is very important. So this one ensures you are receiving accurate and good results out of the qubit analysis. And here is just a small table about, so I compared about what is the difference between the classical bit and the quantum bit comparisons. So if you see here, let me take a pointer. Okay, so here the values stored are 0 or 1 in the classical bit, but in the quantum bit, it is 0 or 1 or a superposition. And the parallelism in the computation, one state at a time. As I already mentioned, it can hold one state, but it can hold many states at once. Okay, the database search can be done only of O of n times, but here it will narrow down. For example, if you want to search for 1 million records or 256 million of records, it will possibilities. It will require if you want to search 1 million record, it will run the query for 1 million times. But here it is a polynomial time. This will take a root of the given number of test steps. If it is, let's for example 1024 step, it will take a square root of that steps, and that will reduce the effort, processing time. Also, it will reduce the compute power required for this operation. That's very important about the quantum. And the factorization of large numbers, this is infeasible for the large number, because the large number, the computation will take a large amount of time. But here the polynomial time using the Shor's algorithm. So the Shor's algorithm will help the quantum computer to crack the factorization of the large number easily. It's like a snack for the quantum bit. And the communication, as I already mentioned, it's a normal transfer. Okay, if the data wants to communicate, it uses the network, but it uses the entanglement and the teleportation for the communication. And the simulation is hard for the molecules. This molecule simulation is hard for the current computer or any supercomputers, but this molecule representation is a natural fit for the quantum systems. So that's very important. And here I would like to also mention a few important things. All right. So this is the important difference between the classical bit and the advantages what we find with the quantum bit. And the next question will be, it's really fascinating, and it's going to save my time, it's going to save my effort, and it is really breakthrough. It's a breakthrough in the computing industry. So the next question will be how to implement the qubits, right? So the answer is it's not easy. It's not easy to implement the qubit. Okay, at the core, a qubit is just a physical system, and with the two distinct quantum states that represent 0 and 1. So the real challenge is preparing, manipulating, and the entanglement and the measure. Measure is drawing the end result, these states reliably. This is uncontrolled. And if you want to manage all these things properly, then we need to have structured thing to implement this quantum computer. So as we are in the early stages or in the mid stage in the quantum computer system, so we need a huge investment at this moment to build quantum computer and the quantum bits are in a functional working situation. And here I just made a quick table. Probably you may take a screenshot of this. Okay, so these are the current available the implementation technologies. Okay, so there's so in the previous sessions, Anand already explained a few things about it. Okay, he discussed about the IBM built one and the Google. So it has some sophisticated quantum computers, and so there are some other computers or some other things are also in the game. Microsoft recently created Majorna 1. So a lot of developments are parallelly happening with multiple competitors. Multiple countries are investing so much here for the better quantum computer to build it. So here the worth mentioning are these superconducting qubits. How it works? It is a tiny superconducting circuit. It's cooled to near absolute zero. And so what is the advantage? It has a very fast gates and already scaled to 100 plus qubits and a strong ecosystem. And just remember, 100 plus qubit means a 2 to the power of 100 possibilities. So that is a big advantage of this technology. And what is the con? Needs ultra cold refrigerators and decoherence issues. So you need to maintain the temperature. So it's really, and it's not always possible. Maybe it's to maintain such thing. It's possible in the Arctic, but in the working environment, in the reachable environment, to maintain such, the cold temperature is not possible always. Okay. The company and the labs developed is the IBM and the Rigidity and the Fujitsu tool. I think I got a question. All right, so this is a feedback session. Sorry. Okay, and so they are trapped ion qubits. The individual how it works? So the individual ions trapped with the lasers and the magnetic fields. And the advantage is it's very stable, high fidelity, and long coherence times. But the disadvantage is it has slower gate speed, which means the processing time and the result, it will time to produce a result. And scaling beyond 100 is tough, which means you cannot go beyond 100 qubits. So that's the limitation of this trapped ion qubits. And the third one, so something's worth mention about the spin qubits, the quantum dots. The electron spin in silicon are semiconductors encodes qubits. And here's one of the, worth mentioning about it. Here we are using the semiconductors, but in the above two one, we don't discuss about the semiconductors. Here it is CMOS is compatible and small in size, scalable on chips. Scalable in the sense, if you want to increase the capacity of the computer, if you want to increase the computing power, then a scalable plays a vital role. If it is not scalable, you cannot increase it or you cannot decrease the size. So scalable is something very important, but as I already mentioned, the controlling it. Okay, so the controlling for the interference is really difficult here. Hard to control reliably and sensitive to noise. Noise in the sense, accuracy will be the problem. Okay, it cannot achieve the high accuracy on the end results. So probably you can spend the time. Okay, so as considering the less time we have, I would like to skip the remaining ones and would like to switch to the next important one, like the qubits. Why qubits are so powerful? What are the advantages it is providing? All right. So here it's a parallelism. Okay, the superposition allows exploring many solutions at once. Which means for example, if you are going to a mall or anything, okay, you have only two hands, right? And you have hundreds of good clothes available, t-shirts available, and multiple shops are there. And it will take really more than a day or two to identify right shop, to find out, the good value item, right? And how about if you think you have a group of 100 people and 100 people can enter into all the shop at once and check everything and just to bring back to you all the results, all the 100 results will be available at the same time. And they also, once another person who is ready to analyze all the 100 things and let you know what is actually required. So this is the one of the best thing across the entire mall. So that's called the parallelism. So this superposition allows exploring many solutions at once, which means it will keep explore all the possibilities on a particular shop or particular given scenario. All right, so this will do all available possibilities at the same time. And imagine in the same example, all the 100 people, and in the mall there are 100 shops, all the 100 people, they have a communication device and they can communicate each other and immediately just saying, okay, this is the best item I found. And this is another best item I found in Levi's. No, I found it in the Shoppers Stop. So if they are communicating each other and they will also, they have a capacity, no, my owner doesn't like this color, he needs that color. So all the specifications understood. So they will all work at the same time to achieve one goal, to find the best t-shirt in the mall with a specific color and the specific size and the specific, the customizations as well. All right, so this parallelism is possible only with qubits, but not with classical bits. Next, the speed. So algorithms like Grover's and Shor's solve the problem much faster than classical methods. So these algorithms will provide the set of instructions, logical things, to solve the problems, to how quickly you can find the solution. Security. So Mr. Anand already mentioned that, okay, it is impossible to break the quantum computers. So the quantum principle led to a new source, secure communication methods, which is quantum cryptography, which is currently no one can break it. So the security will be really good with qubits. Another also, now if you look at this image, probably you can unmute. So what do you think about this image, and can you relate this to quantum computing? You can unmute and share your thoughts about this image.
Is this, since you are teaching this qubit, but what I think is it is related to that several things parallelly working together.
Exactly. You got it. You got it, and you are in a very correct. This is an analogy. So I would like to just mention it. This is the power of parallelism. Okay. So if you compare here, if you see here, this is the single qubit. If you see, this is the, for example, this is multi-qubit quantum computer, and you're researching something which is really complex, and when you trigger the process, and it will invoke all the possibilities, all the possible options, and every single qubit will work as an individual scientist, and you'll do all the analysis with available information and all the possibilities using all the available, the available systems, then it will get you the end result. And this is the power of quantum computing. This is an analogy, not in the same way, but if you see here, all the qubit means it is a power of the quantum compute. Okay, it can do all the validations, all the processing parallelly, simultaneously, and it can give you the result within fraction of seconds. And when you compare this with a classical computer, and this is what you are launching all the possibilities as a single core or the single thread in the computer. Yeah, this is also you can achieve, but if you compare the potential of the quantum computer, the potential of qubits, and what is the limitation of current computing devices. That's the difference. Just a simple example for you to understand. Okay. And our next, what are the applications of qubits? Okay, so the first application is cryptography. So Mr. Anand was already explained about he cracked, multiple, secured systems like the Netflix is broken. All the AIs are broken now. Broken in the sense their pro version, their premium versions are available for free of cost. So such breaking the classical encryption, the SHA-256 or SHA-128. Okay, all these are classical encryption, but this quantum compute, it can create unbreakable quantum keys, which our current modern computers cannot break it. Okay, and so the optimization problems, the faster solution in logistics and finance and the law and the AI. Okay, so the biggest problem with the current AI is you can train it, you can give all the models and you can give all the possibilities, but AI is it using in the algorithms and it uses the algorithms and other things to bring you the best possible solution or the best possible or accurate answers. But still AI is not providing the accurate answers because it's not actually comparing with all the comprehensive or holistic results. It cannot do all the parallelization or all the comparisons, right? But the quantum computer can do this with ease. So let me give you one important, the examples. Okay, so the medicine, the drug discovery. The problem with the classical computer is it cannot create the molecules. It cannot create the actual representation of molecules. So the molecule made up of atoms, and the atoms interact with very complex quantum ways. But similarly, even a small molecule on a classical computer, it takes a huge amount of time and the computing power, which is not actually possible with the current computing device. So that's why identify the finding, you need to take every single possibilities and test it, and you need to research it and find the solution. Again, you go back and test with all the possibilities. That's why, and finalize introducing or innovating a new medicine for the very peculiar diseases takes years together, right? But with the quantum computing, it works as a quantum. So it can easily simulate the molecules because themselves it follows the quantum rules. Okay, what if if the quantum is moving inside, okay, and if any external force hits the atom, it changes the route. It goes in a different direction or the different quantum route. So it can easily simulate it, and it can easily simulate your human body. And in fact, it can easily analyze how this medicine can react with your neurons, how it can react with your blood cells, how this medicine may react with your immune power, or how about the person may have a past history of problems. It can all these possibilities. It can relate with all the possibilities and can draw the accurate results. Thereby, when we have such a powerful quantum computer, medical and drug discovery is going to have a big breakthrough in the future, because it can simulate the human body structure and the atom moving and the way atom is traveling, and it can discover so much things, right? So it can test the new medicines easily, and how the drug interacts with the proteins of the human body. And this could make finding cures for diseases like cancer or any other critical diseases much faster. And another problem is the finance and investment optimization. Hope you would have already heard about the stock exchange, and finding a right task find its right stock, and building a perfect portfolio. Perfect for, let me give you a small example of portfolio means, okay, there are different things in the share markets. You have different components in the share market to invest your things. Okay, mid cap, large cap, a small cap, multi cap. There are so many things are there. Okay, portfolio is multiple way of generating, investing your money. Okay, so each portfolio will have different stocks or different mutual funds, and you have millions of stocks available in the world. How will you know which stock is performing well, which stocks can grow further, and which stock will be the profitable for you, and where you can invest your money? Quantum computer, it can just analyze the past, and it can forecast the future things using the trend available, using the data available, and using the parallelism, and using its multiple parallelism technology, parallelism ability. It can give you a it can help you to build a perfect portfolio to invest your money. So that's because current computing system, it cannot handle such level of possibilities. So this is a bank, and investors deal with thousands of possibilities, stock movements, risk factors, etc. Finding a best portfolio is extremely complex with current system, but the quantum computer can analyze many possibilities at once and find the best investment strategy faster than today's supercomputers. That's the beauty of this quantum bit. And another important thing is logistics. Yeah, you have to to find the optimum, okay, a route for your for the delivery of your goods, or the optimum route for your flights, so that it can easily help you to find out with all the available data. And similar to the cybersecurity and all the with the quantum computing, okay, are also using the algorithms, this is possible. And the next one is the machine learning, the speeding up the certain algorithm with quantum data processing. So that's another big advantage of the applications of the qubits. So the cryptography, optimizing problems can be resolved, and the drug discovery will be simple with, and the machine learning will be easy for the qubits. Although it has a lot of advantages, right? So here we have some challenges with the qubits. Okay, so the very first problem is qubits easily lose information due to environment noise. We discussed about the qubit implementation, right? There in one of the technologies, we discussed about the noise. So noise, okay, it can easily lose the data due to environment noise. So to control this is a bit challenging. We need a strong technology. We need a technology advancement to control this noise, environment noise, so that if the data is lost, for example, let's go back to the same classic example of the mall, finding a right t-shirt, customized t-shirt from the hundreds of shops. Okay, for example, if a single person, he forgets about the requirement you mentioned, then what he will do? He has to come back, collect all your requirements and go back, or he has to call you from there to understand your requirement time and again and continue his analysis. What if he forget about it, then he has to start the analysis from the scratch. So again, it's going back to very bad situation, right? So this T-coherence, the qubits can easily lose information. How you going to control it? So that is one important area. So my beloved friends, this is one of the areas, in fact, you can focus and come up with your own innovation. And this is the gate is open for you. And you can research here to find a better solution for this. Next, the error rates. So the quantum systems are highly error prone. That's why we discussed about the interference. Okay, so we need a better interference technologies to cut off if somebody is searching, you requested for a red color t-shirt. If the person is searching for the yellow color t-shirt, what you will do? Immediately, if you are monitoring it, if you're monitoring, hey, what are you doing here? Or he's requested for the t-shirt, what are you doing in the shoe area? right? So you need to control it somehow. You are wasting the processing time, wasting the computation time. So we need some governance, okay, to control the error rates. So the quantum systems are highly error prone, and we need a stronger algorithms, a stronger governance to timely check and ensure the processing or the analysis is going in the right direction. Okay, and the next is scalability. Difficult to build and maintain a large number of qubits because each qubits, the size is, there is no limit for the size. The qubit can hold a lot of informations, and you need to build such a huge computer. And scalability is currently it is challenge, but this is the current challenge, not forever, right? Because currently we have 8 GB RAM was a huge size few years ago, but it's not sufficient even for your phone. So scalability need to be improved. So these are the areas, key areas where the young generation can focus and come up with your own innovation to solve the problem with qubits. So this is the end of the first topic, qubits, and this is a quick summary. Qubit represents a revolutionary shift from classical computing, and their unique properties like superposition, entanglement, and the interference make them powerful. Just a quick recap. Superposition means it can hold either 0 or 1 as it is continuously checking for the possible solution. And it's called all the possible scenarios. And the entanglement, it's internetwork between or the correlation between each and every qubits. Interference is identify the error and stopping the qubits, canceling the qubits, which is doing the wrong processing, and encouraging the units into qubits which goes in the right direction. That's interference of such a powerful key properties of a qubits. And while challenges exist, qubits are likely to unlocking the future of quantum computing, of course. So I've already gave you 3 important things in which you can initially you can develop a knowledge on the quantum bits, qubits, and come up with your own solution to crack such problems in the future. And I would like to give you a couple of minutes. If you have any questions, probably you may type it in the chat or you may go ahead.
I have a question, sir.
Yeah, please go ahead.
The implementation which you are talking about, machine learning and this optimization problem, this quantum computing or qubit is going to help you. So when you implement something based on like earlier machine learning, many machine learning algorithms are available.
Yes.
So now if you want to implement it on for quantum computing or for qubits, so how do we justify it? Should it be justified based on that time is reducing or accuracy is improving? How it should be justified?
I would say it should go hand in hand. Okay. So from my perspective, reduction of time, accuracy is more important than reduction of the time. Hope you agree with me.
Okay.
Right? If it does the job in half a minute and if it provides a half-baked solution, then it has to do it again. If it takes a little more time, 1 more minute, and provides me the exact accurate results, then I would concentrate on the accuracy and the quality of the results.
Okay, so you mean to say that whatever accuracy machine learning algorithms are providing, if you are making use of quantum computing there, accuracy should at least remain same. Time reduction could be shown, or if it happens like that, accuracy is reducing, but then time is reducing and accuracy is also reducing. Then
if you compare the machine learning with quantum computers, so obviously, if you see in the very beginning, we discussed about the formula, right, for the end result is going to be the number of steps is going to obviously reduced. If it is, it's always a square root of steps required by classical computer. So by default, the time is going to reduce anyway. And in addition to this, accuracy will be exponential based on your qubit size. If you're using 100 qubit or if you're using 200 qubit, then which means the number of possibilities it's going to compare, it's going to evaluate is going to be huge, relatively higher than or exponentially higher than the current computing system. So it's going to draw you accurate information more than our current computer system can provide.
Okay. And does it make sense that you are implementing those algorithms or simulating, actually, I should use that term, simulating those algorithms on system without a quantum computer with you? Does it make sense?
No, it sounds no for me, because without quantum computers, such parallel and the entanglement I mentioned, right? So that's not possible with the current computing system. So every parallel, every processing or every analysis comes with one results, and who's going to combine all the results and evaluate it. So that's because of lack of entanglement or the correlation for every results. Okay, so quantum computer can always can provide a better solution. So such algorithm probably, yeah, if you want to create algorithm for the current, you mean you want to create algorithm for the current systems, current computing systems, right?
Right.
Yeah. So then it's going to be ever refined. The continuous refinement may be required, because the number of possibilities and the computing possibilities also may be increased. But I would say it's like comparing current computing system and the quantum is comparing orange with apple.
Right.
Yeah, because its power is exponential and scalable. But current computer system, it has a limitation because it uses classical bits. Yeah.
Right.
Thank you.
Thank you.
Thanks for your question, Sandhya. Thank you.
Thank you.
Okay, then I'll proceed with considering the interest of the time. I would like to proceed further. Quickly, I will complete the key properties of the qubit. We already discussed about it. So now I would like to discuss about the quantum states. So the state of the quantum is something very interesting to learn. I'm going to wrap up. All right. So I'm going to not take more of your time. Okay. In the quantum mechanics, okay, the state of a system contains the complete information about it. Quantum state describes all possible outcomes of measurement on that system. In the quantum computing, quantum states describe how qubits exist and behave. Every qubit has its own state. And we're going to discuss about, in the next slides, we'll discuss about what are the states currently available and how. So we have multiple states as of now, but I would like to focus on 4 important quantum state. All right, so the quantum state is very, it just describes all possible outcomes of measurement on that particular system. So here, if you see, so the quantum system is described by a vector in a mathematical space called Hilbert space, representing probability of different outcomes. So in the quantum system, it's all about the probabilities. And in a controlled way, so it will do all the probable solution. It will check all the probable solution and get you the required outcomes. So here the first thing is the probabilistic. So the actual result of a measurement cannot be determined in advance. Only the probability can be calculated. Okay, it allows superposition. A system can be in a combination of basis status simultaneously. Okay, so it can change the superposition means it either can 0 or 1, or it can change, and it won't determine the actual result until the final is achieved or until the processing is stopped. Next, as I mentioned, the entanglement, the quantum states can show correlation between the particles that do not exist in the classical physics. So which means it will give you a different perspective of your analysis. The next, the measurement yields a random outcome Okay, measurement yields a random outcome chosen from the probabilistic range encoded by the quantum state. So measurement is a final outcome in a simple word. Okay, so the measurement yields a random outcome chosen from a probabilistic range encoded by the quantum state. So let's compare the quantum state and the classical state now, okay, with all these things. So the property, okay, what's the nature is deterministic. Okay, you can determine whether the switch is on or the off. You can easily determine it. But this is probabilistic. Sometime it may be 1, sometime it will be 0, or sometime it will be off. So it will give a random results because it will do all the possible things, right? So every qubit will hold all the different results based on the end. And the representation, it gives the exact values. If you store 100, it's going to give you 100. But the quantum state, it gives you the probable distributions. And the superposition is not possible at all with the classical state, but the quantum state, it is possible. Entanglement, as I already discussed, it is only present with the quantum state. And outcome of measurement, always the same, but here random, but it follows the probability. Okay. And the next thing is the quantum states. So there are 5 here. I mentioned about 5 states. Base state is it's a common state, which is a computational state. A standard state for qubits, typically 0, a probability of 0 or probability of 1, analogous to classical bits. It's when it is the basic state, there won't be any differences. But when it is in a superposition state, such as the alpha probability of 0 or the probability of beta, which is probability of 1, where A and B are the complex probability amplitudes. It can hold any values. And the entangled state, the 2 or more qubits are correlated, are connected, so that the state of one immediately affect the state of the other, even when separated. Okay, so here in the same mall example, okay, so when somebody already identified the t-shirt of the right size, of the right requested color, then it can inform everyone, hey, I found the t-shirt, let's stop the processing, let's go and present it. Which means the one result of a particular qubit can impact the other qubits as well. So just to give you a small example how a result can affect one, that's an entangled state, means that the interconnected, that's a correlation between all the qubits. And the mixed state, it's a system described by probability distribution over multiple possible states, typically expressed with a density matrix. So it can be at a mixed state, or sometimes it can be a superposition, or sometimes it can be entangled state, it may be a basic state, or so it kind of a density matrix. Okay, and the clustered state and the graph states, highly entangled states used in measurement-based quantum computing, it is always one way. Okay, so it's for example, when you are forcing all your computing power for a certain research or a certain the research of any drug or a medicine, okay, it can take the highly intact, it will be in highly entangled state because it has to do all the possible or probable solutions, and it can use the measurement based one way, which means it will be directed in a very strong and straight way end results for computing. Here, the ground and the excited states are also there. They're used in annealing type quantum, which means you'll have a huge results, and that will be annealing. Okay, it will be annealed into a proper solution. So, like a D wave, where computations seek the ground state of a problem Hamiltonian. There's a topological state also there, which is used in topological quantum computing, which relies on braiding and anions and stores information in the topology of the quantum state for robustness. So it will store the state If it lost the state, then it cannot communicate or it cannot provide you the end results. So the topological state also help you to store the states. And here I would like to just summarize the quantum state type and the quantum computing role. And I give you some example use as well. So the basic use is the fundamental state under the computational basis. Okay, it's like a regular computer. Okay, it's like a simple dollar. And the superposition, as I mentioned, it's a parallelism and the quantum algorithm. There are so many algorithms available. Probably you can read about it in the given. There's so many AIS websites you received. You can explore about what are the source algorithm, and there's many algorithms are available, and you can explore about it. And the entanglement, so quantum speed up, security, and the communication, that's a Bell states. That's an example. And the mixed states, the error correction, and the noisy environments. Okay, so for the example is the density matrix. And the remaining ones were already discussed. So like the cluster graph states and topological state and the ground excited. So this is only for our understanding purpose. Okay, so here it's very high level. So when you are digging deep into the quantum physics, quantum computing, okay, so this understanding will help you to explore more into the quantum computing. So what is important? Why it is so important about the computing state? So quantum states form a foundation of quantum algorithms. So here's a Shor's algorithm we discussed. There are several algorithms available. So the algorithms are written based on the quantum states. So the foundation of the quantum algorithm is the quantum state, whatever we discussed now. The base state, the base or the ground state, or the superposition, entanglement state, or mixed state. So based on the state of the every qubit, okay, the algorithms are designed, or various algorithms can be developed in the future. So the superposition state allows parallel exploration of a solution, as we already discussed. The entanglement provides correlation for speed up. Okay, that's the intercommunications. And the interference helps enhance correct results and cancel errors, as just this quantum states better, pretty, similar to how the qubits also works. So what are the important applications of the quantum states? So the quantum teleportation, transfer of state from one qubit to another. Okay, so the state also will help you to transfer the data, and the quantum cryptography for the secure communication using entangled states, and the quantum simulation for modeling molecules, atoms, and medicines, and finally the quantum algorithms, the Grover's algorithm or Shor's algorithm for the factorization. So, and these algorithms are we have for separate activity, there are separate algorithms also available. Okay, so you can explore more about which algorithm. It's not about you need to develop one, but to solve your problems, the algorithms are already available. Okay, you can explore more about what are the algorithms currently available, and what are the purpose of each algorithm, and which one you can use in your code to simulate some probabilities that you can explore of your own. And what are the challenges currently we have in the quantum states? So the similar challenges what we discussed about in the quantum bit. First, the decoherence, the loss of quantum state due to the environment. It can lose the current state. And the next one is error correction, needed to maintain states reliably. Okay, if the quantum state is lost, then you cannot check, you can evaluate whether it is going the right direction of on the possibilities. And the scalability is difficult to control many entangled states simultaneously. That's another problem. Okay, so these are the current challenges we have with the quantum states. So yeah, these are the key areas where you can bring up your innovative ideas or innovative, you can research and find a probable solution, or you can track how big companies are currently solving these problems by tracking, by keep reading the releases from the news, the letters from those big companies, that you can understand how they are solving these important problems on the quantum states. And now this is the end we reached. I quickly want to give you the quantum state summary. The quantum state fully describes the quantum system and its basis and the superposition, mixed and entangled states. So provides the foundation to develop the algorithms, and understanding the states is essential for harnessing the power of quantum computing. Harnessing this, optimizing or improving or enhancing or reducing the problems. So that's what harnessing means, strengthening your computing. So if you want, you need to have a better understanding on the quantum state so that you can harness your quantum computing. And now this is the time for the quiz. Can somebody please, you can scan the link, and the link will take you to the Mentimeter site. Let me start it. Just give me a minute. I will start the Mentimeter site. Just give me a minute. Okay. Are you able to scan it, and are you able to scan it now? This is the very first question.
Yes, sir. Yes, sir.
Yeah, exactly. Thank you for joining. Only first 50 people will be available, will be allowed. So join quickly so that I can also understand your understanding about how you. So yeah, I'm really glad to see. I will give you a few more minutes, a few more seconds before I reveal the answer. Shall I reveal the answer now? Now, this is the time for you to unmute.
Quantum bit, I think, sir.
Exactly. What's the fundamental unit of the quantum information? Is the quantum bit, which is qubit. Let me reveal the answer now. Okay, so quantum bit is the correct answer. And let me go to the next one. A qubit can be?
Sir, a superposition of 0 and 1.
Yes, but you don't reveal the answer on the speaker. You can click answer on the link, and so that. Yeah. Okay, great. So good to see good responses on this. Okay, let me reveal the answer now. So it's a superposition of 0 and 1. That's the answer for this qubit. Qubit is 0 and 1. And the next question is, so true or false? Measurement collapses a quantum state into either 0 or 1. Yeah. Okay. Let's see. Let's wait for a few more seconds. I think a few people are answering correctly now. All the blues are the correct answers. Yes. The collapses in a quantum state, it can be either 0 or 1 based on the probabilities. Okay. It can be either 0 or 1. Yeah. Really, you guys are doing a good job. I'm really glad about it. And this is the next question. Which property allows the qubit to exist both in 0 and 1 at the same time? Let's see who's going to answer this correctly now. Yeah, some balls are loading. Keep loading. Exactly. And this is the right answer. Superposition enables you. That's why it's a superposition. It can be either 0 or 1 at the same time. Entanglement is a correlation, the communication between the each qubits. Measurement is to drive the end result. And encrypt quantum data is not in the list. Okay, which of the following technology is commonly used to implement qubits? We discussed about that in the companies, we discussed about it. I gave you the clue. You can let the ball roll for a few more minutes. Yeah. Okay. I think you guessed the correct answer now. And because you know the right answer. Yeah, superconducting circuits. Silicon chips, it's not the suitable for this at this moment. Magnetic tapes, not in the scenario at all. Okay. I think this is the last question, I guess. The block sphere is used to represent. I think it's a bit difficult one. All right, it's time to reveal the answer. All possible state of a single qubit. Okay, the block sphere is a widely used, important one. Okay, let me go to the next one. Yeah. All right, that's the end of the quiz. Okay, let me come back to the slides. Yeah. Hope you really enjoyed the session. So I planned for a little longer time, but I cut short in the possible places and to wrap up the session. Hope I delivered something informational for you. Okay, hope you understood. You got understanding about. I'm not going to say you got the complete understanding about the qubits and the quantum status, but now you grabbed some knowledge about what is a qubit and what is a quantum state, and that's really amazing. Yeah, I saw Papati raised your hand. Yeah, please go ahead.
Papati, do you have any question?
All right. Okay, thank you. And I would like to thank the coordinators and all the HODs and all the important people in the department for providing this opportunity. I take this moment to show my gratitude, and I would like to thank you, every one of you, and investing your time in grabbing knowledge on this quantum bits and the quantum state. And I really appreciate all your time, and thank you for your interest, and keep the vibes, and explore more about the quantum computing, and all the very best for your future. And thank you.
Sir, could you please write your email ID and phone number in the chat box?
Sure, I will. Chat is disabled for me, ma'am. Could you please?
Then please dictate your phone number, sir, please.
Yeah. Or let me write my phone number on the screen. Just a
Okay,
moment.
yeah, sure.
Okay, pointer pen. Just a moment. This is the best way then. This is my phone number. And this is my mail ID. Okay, probably you may take a screenshot for the quick reference.
Sir.
Yeah.
Yes.
You may write. Yeah.
Yes, sir, it's visible, sir.
Okay.
Sir, I missed it. Email ID. Kindly show that screen again. Yes.
Okay.
Just Robin.
Ma'am, we will share in the group, ma'am. Don't worry, we will share in the WhatsApp group.
Okay.
Yeah, I can share in the group now.
Yes, sure. Thank you, sir.
Sir, I will share, sir. We have separate group for participants. I'll share there.
Okay. And one more thing, I'm also available on the LinkedIn. I'm really happy to connect with every one of you. You can find me on LinkedIn. All right. And thank you, everyone. Thank you, ma'am.
Sir.
Yes, thank you,
Yeah,
sir.
just I'm
Nice
going to
session.
deliver vote of thanks, sir.
Thank you.
Just wait for a few minutes, sir.
Yeah.
So thanks, Robin sir, for such a wonderful session. And this session explored the core elements of quantum computing, quantum bits, quantum states, which form the foundation of quantum information processing. You have explained the application of quantum computing and challenges of qubits. So unlike classical bits, qubit can exist in multiple states simultaneously due to superposition, enabling quantum computers to process information in parallel.
Yes.
This session discussed how quantum states are presented by vectors in a complex vector space where measurement collapses these states into definite values, fundamentally altering how we approach computation. Understanding this principle is crucial as we move toward the future where quantum computers can solve problems that are currently intractable for classical computers. With this, we are closing day one of the FDP. Thanks to all participants for joining the session of day one. We will see you tomorrow for the day two sessions on quantum algorithms and computational complexity and quantum circuits and gate models. Thank you all.
Thank you.
Thank you, sir.
Go and end the session, and recording will start. Okay, we have to wait for.